First Mauritian satellite, a CubeSat, Measat-1, was successfully launched today on board the SpaceX Falcon 9 rocket mission, SARS-22/SPX-22, from the Kennedy Space Center in Florida at 5:29 p.m. UTC. The Mauritius Imagery and Radio Telecommunications Satellite 1, Measat-1, was built by a team of researchers at the Mauritius Research and Innovation Council, MRIC, under the auspices of the Ministry of Information Technology, Communication and Innovation. The local amateur radio society also supported it in collaboration with experts from AAC Clyde Space UK. Mauritius was the winner of the third-round Ungana/JAXA Kibo Cube program in 2018. JAXA awarded the nation the opportunity to build and deploy a 1U Cube satellite through the International Space Station, ISS. In February, Measat-1 was handed over to JAXA to be deployed from the Japanese experiment module, Kibo Cube on the ISS. The primary objective of the Measat-1 is to acquire satellite technology through the design process, design review, assembly, integration and testing. In parallel, the MRIC has set up a ground station located at its premises in eBay, which will serve to control and operate the Measat-1. This ground station will also allow the receipt of data and telemetry from other satellites. The ground station is being equipped with a flat-sat module, a replica of the 1U, enabling engineers to simulate all the required maneuvers before sending the command to the CubeSat. The flat-sat module is a key tool for the Mauritian engineers to design future CubeSats after the Measat-1. The Mauritian Measat-1 is Africa's second satellite in 2021, bringing the total number of African satellites to 44.
Africa needs to be in space. There's no choice, in my view. Being behind in that area costs African nations quite a lot. For instance, for communication, for telephone, for education, remote education to their provinces and stuff, they pay hundreds of millions of dollars rent to get the bandwidth from private satellites and so on and so forth. Even, if you look at that, it'd be enormous saving if they had their own communication satellite. And also now, with the miniaturization that I mentioned, you have CubeSats. They're like 10 centimeter cube. And that's one unit. You can have a 6U where you can have quite a few things. And that you can launch.
Is that what we hear when we, for example, like Uganda sent a satellite to space recently, and
Kenya did one.
Yes.
Yeah. Actually, what's different about the Kenyan satellite? It was built by engineers from a private company in Kenya. That's a departure from
private sector investment in space in Africa is happening,
and was launched by SpaceX.
Yeah.
And so. That's very early stage, but it should be encouraged. I think Africa is wasting quite a bit of resources through internal wars and stuff. I'm not saying it's only in Africa, because wars happen around the world, as we know now. But leaders should make every effort possible to avoid these things and focus on what's important for the future. Being present in space is controlling your own financial transactions, controlling how you grow crops from space. You can map, you can see where moisture is low or high, and so on and so forth. It's even important for national security. So it's not a choice. You have to be there. And to do so, I think regional cooperations,
yes.
like Kenya has on San Marco Island, a launch pad that Italians use. It's near the equator. As you know, when you launch from the equator, you get the Earth rotates faster at the equator, so you get all that velocity attached to it. And so, the launch could be in Kenya. The satellite could be assembled in Uganda. Some of the electronics could be done in Ethiopia and so on. And
research happens some other places.
Yes, absolutely. It's not prohibitively difficult.
Right. Prohibitive in terms of resources could be, but when you pool resources, I guess.
Absolutely.
But is Africa falling behind the space race at this point? Is that something that worries you?
It worries me, yes. Nigeria has done several iterations of space launch. For instance, they hired an English company that did their first satellite. They had their engineers go in England to work, but now they're gradually moving the control center in Nigeria and then doing some of the work in their own. So there's a lot of not highly organized Africa-wise, but these countries are trying.
Africa in space? I'm sure you haven't heard that before, but it seems it is going to be a term that we'll be getting used to in the near future. Did you know that South Africa, Angola and Algeria have a satellite in space, and now Kenya has entered the race with the blasting off of its Taifa 1 or One Nation rocket? WION spoke exclusively to the engineer at the Kenya Space Agency. His name is Lieutenant Colonel Andrew Nyawede, on what other African countries need to do to better their space exploration capabilities. Watch this next report.
3, 2, 1, ignition, engines full power, and liftoff of Transporter 7. Go Falcon, go Transporter.
Kenya's first operational satellite is launched into orbit by a SpaceX rocket called Taifa 1 or Nation 1. The satellite was designed and developed by a team of Kenyan researchers. The space agency says the satellite was put together with the help of Bulgarian aerospace company Indurosat at a cost of 50 million Kenyan shillings or approximately $372,000 over 2 years. The agency says it will operate for 5 years and then decay in over 20 years, entering the atmosphere and burning out.
Okay, the main challenge we faced was lack of facilities locally to develop the systems, because this requires a clean room facilities, it requires manufacturing, assembly, and test facilities. Currently, we don't have in Kenya. And then there's also, arising from the COVID-19 pandemic, a shortage of electronic components. This delayed the project timeline. But overall, budget constraints limited us to the type of mission to develop.
21 years after the first African satellite, Sunsat-1, was launched into space by South Africa in 1999, the industry has accelerated with hundreds of millions of dollars investment into it. The last 7 years have been very successful for the African space scene. A total of 20 launches have taken place since 2016, totaling 41 satellites being sent into space. Egypt leads the way with 9 launch satellites, followed by South Africa with 8, Algeria with 7, Nigeria with 6, and Morocco with 3. Ghana, Sudan, Ethiopia, Angola, Kenya, Rwanda, and Mauritius complete the list.
Okay, the aspirations in space exploration vary from national prestige to scientific knowledge and advancing technological capability. And for Africa, I believe with the current priorities now being on food security, natural resources monitoring, meteorology, disaster risk mitigation, and I'll call it communications, this would now be the priority focus areas.
In January 2016, African heads of states and governments adopted the Africa Space Policy and Strategy to facilitate growth and development across the continent using space science and technology. The African Space Policy and Strategy promises to initiate space capabilities on Earth observation systems, navigation and positioning, satellite communication, and space science and exploration. Some African countries have also developed national space policies and strategies. In some countries, academic programs have also commenced in areas such as astronomy, remote sensing, space weather, and satellite communication.
We are creating awareness. Policymakers, academia, to the public on the benefits of space. This now will enable us now, one, get support for more funding, and two, sensitize the public to support these programs, because without public support, funding is usually a challenge for most countries. So for Kenya Space Agency, we are looking at increasing our investment in space, both for the country and for the region. And I believe there's a greater benefit for us.
But the challenge is that there are few jobs for the graduates. Africa eventually loses them to countries where their knowledge and skills are better used. Critics say it is key that African countries continue to increase their investment in the space sector. Bureau Report.
Picture this. It's February 1999. Pluto has regained its status as the outermost planet in our solar system, and NASA just launched the comet probe Stardust, which would return the first extraterrestrial sample to Earth. Meanwhile, on Tuesday the 23rd, at the University of Stellenbosch in South Africa, postgraduate engineering students are about to watch the launch of their satellite, SunSat-1, the very first to be designed and manufactured in continental Africa. Following this groundbreaking achievement, the space industry in Africa developed exponentially, with hundreds of millions of US dollars invested. More than 23 satellites were launched in the past 4 years alone, making 44 satellites at a grand total of over $4.5 billion. And according to the 2021 edition of the Africa Space Industry Annual Report, 125 new satellites are lined up for development in 23 African countries between now and 2025. To coordinate and manage Africa's growing space activities at a continental scale, the African Union eventually passed the 2017 African Space Agency Act. It remains the first and only legislation governing space activities in continental Africa and establishes the African Space Agency. The purpose of this agency is to lead, promote, and unify work in African space policy and strategy. It aims to support the African Union's Agenda 2063 for the socio-economic development of African countries by exploiting space technologies, applications for sustainable development, and citizen welfare improvement. The agency will be based in Egypt, who allocated $10 million in a bid granted by the African Union to host and establish these operations that are expected to be fully underway within the next few years. However, there are a number of challenges in the full implementation of this agency. Its status as an organ of the African Union Commission, rather than its own specialized agency with full political and financial autonomy, has caused some limitations. To overcome these obstacles and facilitate the growing space enterprise in Africa, increased national collaboration and independent capacity-building efforts will be vital. The African Space Agency Act does much more than establish the African Space Agency. It establishes a strongly planted foot in Africa's reach for the stars. It represents Africa's first practical step towards the advancement of their continent-wide space program and the peaceful, collaborated use of outer space. To learn more about the African Space Agency, head on over to spacetv.net for all the latest news. For Space TV.
Okay, so as we are getting ready to restart our session, this session we're going to go straight into the afternoon, talking about SDGs for space. We have two panels back to back, and then be guided by Toby Thomas, who is part of our crew and part of the analog astronaut community. But we've been talking a lot earlier today about partnership for prosperity, and we wanted to launch this session before you start listening to the speakers with a message from the UN South-South Cooperation Office. I had an opportunity to speak with them about this issue, this agenda. I did not know if it's something they're talking about, but certainly by the first set of conversations we've had, it's a new topic on the agenda for them as well, and our hope is that we're going to get them involved in supporting the relationship between and within African countries and universities and NGOs. So we'll be able to bring from Cote d'Ivoire and Ghana to East Africa and back and forth, the people from Botswana who want to be part of this community of practice. We're going to see how we can develop a platform and support for the intra-regional, intra-African conversation to continue. So I'd like to share a presentation prepared by Zanofer Ismailebe, who is at the UN Office for South-South Cooperation. Please listen and let's digest this information. He's not live, he set a recording because he had a board meeting all week. But please, certainly if you have questions and concerns, make note of them so I can relay them to the office, because I do plan to be with them in New York to follow up on this. Thank you. Will you play the video, please?
Good afternoon, everyone. My name is Zanofer Ismailebe. I'm the Chief of the Knowledge Management Team at the United Nations Office for South-South Cooperation, based in New York. It's a pleasure to join you all virtually at this forum today, and would like to thank the organizers for the invitation to the UNOSSC. It serves as the focal point to advocate for and coordinate South-South and triangular cooperation on a global and UN system-wide basis. With regards to the topic of this roundtable, STEM matters: science, technology, engineering, and mathematics. Skills and experience are not only integral to building STEM workforce for research and other high-value jobs, but also critical to developing new products, scientific and technical knowledge and ideas. Investment in STEMs pay rich dividends to countries at every stage of development, especially if they educate diverse groups, champion inclusiveness, and foster opportunities and advancement, especially for women. Yet, from the perspective of access, equity, and inclusion, the capacity for scientific innovation remains unequally distributed across the globe. STEM is expected to play a significant role in the success of the implementation of the 2030 Agenda and the African Union's Agenda 2063. Both agendas, as you all know, emphasize the role of science, technology, innovation, and scientific research in underpinning sustainable development. According to the African Development Bank, less than 25% of the African higher education students pursue STEM-related career field. STEM is arguably the most important field that would drive the socio-economic development of Africa quickly. The fact that only a few young Africans choose to pursue STEM-related career fields should be a concern. It potentially means that regardless of Africa's talent pool, public and private institutions would have to source workers in those fields from outside of the continent consequently, leading to a limited domestic STEM workforce. Dear participants, STEM education inculcates problem solving, critical thinking, communications, collaboration, and digital skills. Youth need these skills to build the resilience to navigate an uncertain future where technological advances will fundamentally alter industries and eliminate about one-half of the jobs today. Similarly, closing the gender gap in STEM education is also a key. Women are key to addressing the existential challenges that face the continent and beyond, as some of these challenges transcend boundaries. Regional economic communities such as the African Union and ASEAN and strategic initiatives among a group of countries such as IBSA, the India, Brazil, and South Africa, and BRICS, Brazil, Russia, India, China, and South Africa, have been active in sharing technology among southern partners and implementing programs and projects on a number of themes. Such regional economic opportunities and communities have become a conduit for South-South cooperation in science, technology, and innovation. For the UN Office for South-South Cooperation, this has been one of the areas that we have been working on. For example, the UN OSSE, in partnership with the African Union Commission, has organized a series of webinars highlighting the positive contribution of African women in STEM to the COVID-19 response. Seeking to contribute to the body of knowledge, the initiative brought together ICT practitioners, scientists, and other African women involved in generating homegrown solutions and their experiences in responding to COVID-19. Under the Youth for South initiative, UNOSSE, together with its partners, has been working to promote youth, particularly early career women scientists, to foster careers and strengthen the expertise of young researchers from developing countries from South America, Africa, and South Asia. Similarly, the UNOSSE, jointly with the African Union Commission, launched an initiative on African women in innovation, science, technology, engineering, and mathematics, WISTEM. This WISTEM initiative resulted from the identified barriers that women and girls face in STEM and the desire to address them. The initiative aimed to provide all-encompassing initiative that creates opportunities for synergies and is a one-stop shop facility that optimizes opportunities for African women in STEM, which is currently lacking. The main strategy was to establish the initiative as a functional and sustainable ecosystem to improve the participation of African women in STEM by leveraging the power of South-South cooperation. In conclusion, the UNOSSE, through its South-South Galaxy platform, which is an online global knowledge sharing and partnership brokering platform, provides a digital depository of good practices, including those on STEM. For example, the coding camps and ICT training for young girls in Africa by the ITU, UN Women, and the African Union Commission. The project reached out to more than 500 girls and equipped them with appropriate skills to pursue higher education and employment in ICT. The initiative exposed the girls to a wholesome learning experience with a primary focus on building their coding and leadership skills, as well as opportunities for peer-to-peer learning, sharing, and collaboration. Through these camps, the participants from across the African region shared experiences in terms of strategies, approaches, and used by their respective countries and educational systems with the aim of supporting girls to embrace science, technology, and innovation. I would like to encourage you to engage on this platform, which not only will allow you to access and share knowledge, but can also facilitate in identifying areas for joint and collaborative activities that are best suited for matching needs. On behalf of the UN Office for South-South Cooperation, I would like to reiterate our commitment to work closely with you all to take this agenda forward through South-South cooperation. I wish you all a fruitful discussion ahead. Thank you.
Thank you for that. Can we do a round of applause for our additional speaker?
All right, so we're going to go into our afternoon session, and I've been trying to get the other speakers for today at 1:30, 1 o'clock in the room. Could you please join us on stage? We're going to get right started. Are they in the lunchroom? We're supposed to have Dr. Obonyo, is he here? Dr. Sunday Abuja, is he here? Could you please join us? No, you go on the other side. You sit here. You sit. Yeah, there we go. All right. So we're going to ask, so Dr. Edgar Mensah should have been the moderator for this session. He's with the African Association for the Development of Technology and also faculty member for National Polytechnic Institute. However, in Cote d'Ivoire, which is National Polytechnic Institute, Felix Houphouët-Boigny. right? So he is caught up in a visa tangle. I would like to comment that it's unfortunate that people from Cote d'Ivoire need visas to come to Kenya because one was formerly Francophone and one is Anglophone. But hopefully he'll get here by tomorrow and we'll have an opportunity to at least present his research. He wanted to talk about what he's doing in energy. And he's supposed to be going to Marseille with us as well to begin to scope out the research that we'll be doing at Oaseas. Let me introduce Toby Thomas, who is a part of our mission crew at the Oaseas project. He's an environmental science educator and also an accomplished analog astronaut. And so I've asked him, in addition to, or instead of doing his regular speech, to moderate instead. So Toby, the floor is yours. Thank you.
Thank you, Dr. Nelson. So we are here. So we've already introduced some of our speakers that are in person, but we're also going to give them a chance to give a little talk about their subject matter. So first, I would like to have, let's have Dr. Sunday Abuje speak first, and the floor is yours.
All right, thank you very much. My name is Sunday Abuje, as we indicated. I'm a landscape architect, environmental planner, climate change expert, as well as urban planner. And my interest in this is basically within the context of Earth observation from space and how this affects the built environment, as well as its contributions to matters biodiversity management, as well as urban planning and development of urban neighborhoods. I have a brief presentation that I can request them to share on the screen so that I can then take us through briefly. Right. Thank you very much. So I'm looking at the nexus between the built environment, climate change, and space science with some local case studies. So to start us off, my presentation will basically be within the following context. One is give a general context and where the SDGs fall in. Then I'll talk about urbanization in the built environment. I'll talk about climate change in the built environment, and then I'll finalize with what are some of the successes, gaps, and opportunities, and the role that can be played by space science in all this. So if I start with the introduction and the context generally, when we look at most of the global challenges we are facing at the moment, they can very easily and quickly be summarized within the context of the SDGs. And interestingly enough, when I looked at the brochure by, I think it's called Digital Earth, they seem to have highlighted very, very similar SDGs. We're talking about life on land, life in the seas, urbanization, we're talking about sustainability and all that. And all this falls within the realm of the built environment, where you have professionals such as landscape architects, engineers, quantity surveyors, construction managers, planners, climate scientists, environmental scientists, and all that, who can play a very, very significant role in this. But why is urbanization very, very critical? A very big population of the world resides in urban areas, and a lot more people are moving into urban areas. But there's very, very limited understanding of how urban areas have been growing. So for instance, we have roughly about 57% of the world population in urban areas. It's slightly smaller in Africa and the developing world. However, these are some of the fastest growing urban neighborhoods that we are looking at. However, at the same time, we lack critical, historical, and Earth observation information that can assist us in appropriate planning of such areas. If we go further and we look at a case of Nairobi, and I'll just give you two scenarios: observation of Nairobi as a city from the ground and observation from an aerial perspective. If we look at how Nairobi has been developing over time, we have had very significant land cover changes that have happened. And this has basically occurred within the context of replacing the existing natural environment with built-up environment, where eventually you started with a settler neighborhood and then a railway town, and this developed into an urban area and culminated in what you're seeing at the moment. However, if you're looking at the same city from space, you get a very, very different perspective, where you're able to study the where and when the change is happening. And this provides a very, very good opportunity for us to be able to critically assess how development has happened, how development is happening, how that is affecting biodiversity, and how that is influencing other facets of the SDGs that you're looking at. This therefore then provides a very, very critical opportunity for us to also bring in another perspective of climate change. This is one of the most urgent challenges that we are dealing with globally. Climate change is contributed to by urbanization, but urbanization will also be able to provide very, very ideal opportunities for combating climate change. If we look at, for example, greenhouse gas emissions, most of them are generated from the built environment. And that therefore then means that if we are able to leverage technology for purposes of developing very appropriate and well thought out urban built environments, then we have a very, very big opportunity to deal with the challenge of climate change. This requires or manifests in very, very different ways. We have increasing disasters to do with drought and floods. We have increasing challenges of heat waves and cold waves. We have increasing challenges of extreme wind speeds. And we also have increasing challenges of flooding in our neighborhoods. How can all this fit into the global scenario? The latest report by the IPCC notes Africa as one of the key places that suffers the most, but contributes the least. However, if you look at it within the context of the space race that we are looking at and some of the news reels that were being cast on the screen, we are the last in terms of foray into space. Yet, the science that is likely to leverage our ability and potential for discussion actually exists in space. We are the least polluters, but we suffer the most the consequences of climate change. But how can we defend ourselves? By making sure that we have robust Earth observation information, data, and technology that we can then now use to argue our case in terms of the impacts that we are feeling and how this is affecting development within the developing world. I'll close with some successes, gaps, and opportunities, especially from the context of the built environment. There is some limited free information or data, especially from Earth observations. And this is limited in the sense of level of clarity or detail of information. You have to request and wait to be able to get that information. There's also limited collaboration, and part of this is on the fault of lack of putting that information out there. I just came across one of the brochures and one of the speakers here was talking about free data. And for the longest time, we do not think free data existed out there. The most we could get was from Google Earth. So we are equally extremely shocked that some of this information is actually readily available. And I think it will be freer when we have our own satellites and our own astronauts going into space, because they understand our own local challenges. The other challenge that exists, and one of the key gaps, is that most of the information that is out there from Earth observation is not tailor-made for us. The people who send the satellites fashion the information for themselves. So we have to look for what we want within what they have provided. If we had our own abilities, then we would be able to tailor-make exactly what we need and how we need it, whether we are using it for agriculture, whether we are using it to observe climate, whether we are using it to look at matters of urbanization. And I can contribute by looking at a local scenario. If you look at our country, Kenya, what you're seeing on your screen is the distribution of weather stations. For a country as big as ours, if that is what we're going to rely on collecting climatic data, then we're going to have a lot of challenges. Because if you look at the northwestern part of this country, there is barely any weather station. So what does this mean? Does it mean that we don't have climatic information or urbanization information for that particular area? And how does this limit any activities that will be taken within such localities? So finally, I would then say that we might need there's a lot of work to be done, but space technology is the way to go, and it will allow us to transform from that into this if we are looking at the context of urbanization in the built environment. Thank you.
You know, Dr. Abuje, what you were saying with the climate change perspective is such a huge thing. It made me start thinking about just even here in Africa, our relationship with water. Very different from other places around the world. If I say something like bucket showers or bucket, people know what I'm talking about. If you go to some place in the world, they have no clue what we're talking about because they just have showers and wasted water, but we use water very efficiently. So that climate change perspective, I think we can really contribute to the world's understanding. So I think we're gonna have a really rich discussion in a bit. So next, I would like to bring Dr. Willis Obonyo to speak about his field. So here we are, stage yours.
Thank you very much. I would like to stand there, sorry. I have a slide as well. Maybe bring it up, kindly.
Dr. Willis, could you tell us a little bit about yourself in the meantime while your slides are being...
Okay, so it seems like my slide is getting longer than I planned. I'm Willis Obonyo, currently a lecturer at Technical University of Kenya in the field of astrophysics. I have a PhD from the University of Leeds in astronomy and astrophysics, master's from the University of Cape Town in astronomy and space sciences, another master's from Moi University in nuclear physics, and a BA from Moi University as well in physics. And my presentation is basically on education in the field of astrophysics. Thank you very much. So what I'm going to share here is the research that we're doing at Technical University of Kenya. We are not astronauts, so we can't go to space, but we can observe what happens in space. And that is what I'm going to share with you here today. What you're looking at there is two students on the left, our undergraduate students working on a project in Ileret in Ungana, optical astronomy to observe, they were observing what was called DART project, which was a way to see if we can displace the path of an asteroid just in case it was harmful to us. On the right, we have undergraduates working on a radio astronomy project. So introducing them to radio astronomy using tabletop radio telescopes. Here, so we looked at African Outer Space Program, and our relevance is on astronomy and space sciences, and that is what I'm going to talk about. This is the same one. The left image is sponsored by the COTI, Kenya Optical Telescope Initiative, led by the University of Edinburgh. And the one on the right is sponsored by the University of Leeds, and of course in collaboration with the University of Manchester. Now, I just want to share with you what our PhD students are doing. So apart from our graduate projects that we do, we also have PhDs and postgrads to be general. So these are PhD students called Isaac Montier. He's working on a radio astronomy project in collaboration with the University of Manchester. What you're looking at there is what he's studying. I don't want to go into details, but that's a jet of a galaxy. It's like extragalactic astronomy. Here is a work that is done by Geoffrey Ongado, who is also a PhD student. He's looking at diffuse emission, radio emission from some galaxy clusters using the telescope called VLA, which is in New Mexico, Socorro. So he's using data from VLA, a very large array in the US. Here is Dorcas Doki, who's also doing a PhD. She's working in collaboration with a team in Spain, and she's looking at kinematics of galaxies. She's looking at the gas dynamics of gas flows, how that affects the evolution of galaxies and stars in the galaxy. She's looking at using data from ESOs VLT at 8.5, which is 8.5 meters in diameter. There we also do some work on machine learning. So this is work that was done by one of our MSc students, Vincent Okot. He's looking at gravitational waves, synthetic gravitational wave signals. There are signals that of gravitational waves, and there are also data, which is pure noise, and is writing an algorithm, using algorithms, machine learning algorithms, to write models that can try to predict, identify the gravitational waves from noise. And then next, we also have those who are working on galactic astronomy. So astronomy can be classified as galactic or extragalactic. What happens within our galaxy, we call them galactic. So on the left are some regions of ionized hydrogen. Some of us are studying it. Moses Langa is doing it at PhD level. And on the right is results by Calvin Juma, who's also doing it at MSc level. They are slightly related, but different a little bit. This is also what I work on, close related to them. I study the university stars, but when they're driving out jets, so there's a stage where they drive out jets, and that is what we are looking at, the different kinds of objects and their properties, how they behave. We'll see if we can unravel some of the features. Apart from that, we do hydrodynamic simulations. We were privileged to get a server that we can use as CHPC, as high performance computing, that we can use for simulating some of these objects. This is just one of them that I've shown, but there are others that other people are working with on. And here, our collaborators, University of Manchester is co-supervising one of our PhD students, University of Edinburgh is co-supervising our MSc student. The Institute for Astrophysics in Spain is supervising one of our PhD CHPC, helps us with the facility for simulation. And we're very grateful. And the University of Bristol is also co-supervising one of our PhD students. Thank you very much.
Wow.
So Dr. Bonio, I like what you were talking about. When you mentioned all your background with physics, and we were having conversations with some of the participants yesterday about the mindset that studying physics allows you to approach, like a systematic thinking. And it falls right into the SDGs we're going to talk about a little bit later. Do we have any online speakers that? Okay. So while we're trying to set them up, the communication between environmental scientists and astronomers, I think, is a powerful tool. And have you two seen the communication happening between the two, especially here in Africa, to move forward our understanding about climate change and so on?
All right, maybe from the perspective of environmental science, I think one of the biggest challenges we face is we don't talk to each other enough. A lot of us are doing great things, but in different spaces. So I must confess, for example, that from the built environment, we are more or less end result consumers of the outputs of other people. And because we don't give adequate feedback, they don't know what to output for us. So we might keep complaining that this is not being done, but we are also not appropriately communicating what is it that we require. So I rightfully agree with you that whatever he was talking about sounds very interesting. And it is a discussion that we need to have as environmental scientists, built environment professionals, physicists, astrophysicists, astronauts, and all that, so that our information can be able to flow and encourage a lot of multidisciplinary approach to dealing with the SDGs as challenges that we face globally.
Thank you very much. I think there are areas that we can collaborate. The technology is similar. The instruments that we build use similar technology. So I think we can make use of the technologies, especially the machine learning area, even the satellites, take images that we can analyze with our technologies and the skills that we have. So I think there are areas of collaboration.
Yes. Introduce.
Yes.
Okay, so we have another person that's going to be on our panel here, and he actually has a satellite demonstration here with us. So I'll allow him to introduce himself in just a bit. But one thing I want to say with what you were speaking about, Dr. Oaseas, so space weather and weather that we're experiencing on Earth. You know, some people are familiar with weather on Earth, but we're not really too familiar with space weather, but they really interact with each other. So the people that you're working with that are studying the movement of stars and all of that, I'm pretty sure we can find a way to expand our understanding as environmental scientists into how space weather impacts the weather that we are observing. So yes, please, I'm gonna pass the mic over and allow you to introduce yourself and tell us a little bit about how this is related.
Hi, my name is Vigil. I'm an aerospace engineer at the market space. My colleague there is Gerald. He's an electronics and electrical engineer. So we have realized that in Africa, and especially in developing countries, there's a lot of problems with lack of access to education and practical hands-on experience in both satellite engineering assembly as well as the course content. People don't know where to start. They don't have access to information. They don't have access to the practical and assembly bit. And also testing facilities are very scarce, and there's currently none in the continent. So we sat back and looked at this problem. So how can we solve this in a single solution that's affordable for every university and institutions around Africa? And we developed a satellite model training kit that runs with the powerful Raspberry Pi 4B that also operates on current CubeSats. It runs an RTOS and open source server that can be used anywhere. Charges via solar, so you can use it in any grid solution. So it means that it doesn't matter where you are or where you come from. Even if no matter how remote the area you're based in, you can still be able to learn hands-on assembly of a CubeSat. You can see how all the systems are able to be assembled. It's very extremely modular, so you can carry it and it can work from a mobile phone, from a computer. As long as you have the sun, you can basically charge it and access it wherever you are. So it's modeled on existing CubeSats. We have the OBC, the onboard computer, the ADCS, which is an open source sensor board. And what's interesting is that the entire system is not just designed locally by us, it's also assembled locally, it's also manufactured locally. The PCBs are in partnership with Gearbox and wherever the structure and the other parts are. This is the only thing that we actually managed to import, because we're looking at a local solution to a local problem, was the microcomputer. But Raspberry Pi has been talking to Gearbox, and there's also semiconductor technologies hub in Deco, if you've heard of it. So they're manufacturing microchips. To manufacture Raspberry Pi 4 easier, so soon it will be 100% locally produced. So we're looking at having a system that not only mimics existing CubeSats and gives that access to skills and hands-on experience, it also has different layers of complexity of courses. Like you have the beginner courses, which are also accessible within the CubeSat. So the beginner courses are for people who are in high school, people who don't have very heavy engineering experience, but can still be able to understand, okay, this is the overview of how a satellite works and how space systems work. And then we have the intermediate, which is maybe engineering students who have some sort of understanding of the engineering mechanics of satellites, the space environment and the complexities, the challenge you need to overcome. Then you have the advanced PhD level and so on, where you can get, the sensor board is very modular, so you can prototype existing technologies. If you look at current solutions, for you to prototype, you have to develop a new board to communicate in CubeSats. It's very expensive, about $10,000, because you have to first get space qualification. You have levels 1 to 9. They're called technology readiness levels. So you have one that has never been to space is at 1. You have 5 that have maybe gone through space test, vibration test, and so on. And you have 9 that have space heritage. So how do African countries get that? They don't have the funding, they don't have the money, they don't have the knowledge. But using this, you can prototype those boards that you want to send to space and see if they work on a real satellite before sending them to spending $10,000 and above to send them to that mission at less than a tenth of the cost. Actually, it's at 1/20 of the cost and you can easily upgrade and add new parts, test new components and so on. So I think that's just a rough overview of what we're trying to do. And let's say any questions.
Yes, thank you. There was something that we mentioned earlier today about consumption that we've just been consuming from outside. But one of the SDG goals, SDG, I said goals, G stands for goals, so stuttering there. But one of the SDGs is the sustainable development, looking at responsible consumption and production. Now, with what we've been talking about, there are certain things we want to measure with the environment. Having our own satellites with our own sensors specifically geared to measuring those things, that would be a game changer for us here in Africa. And I just wanted to get a little bit of your, and you spoke a little bit about the different levels of engineering and the way you're communicating it, but a lot of spacefaring nations that are higher up in the spacefaring, they found a way to embed STEM into their curriculum in a fundamental way. So what you're doing is that one of the steps that we're looking to embed STEM into our curriculum in a fundamental way?
Yeah, because for example, if you do not even need to university to learn how to engineer satellite using this kit. Because the thought process that we had was that for the advanced level, I interacted with Stanford and other universities that have developed fully integrated engineering courses from Oaseas systems to OBC to thermal and so on and so forth. Those are, so they teach you how to assemble and manufacture and put together a satellite, how to test it, how to model it mathematically, and so on. And it's all within the satellite. You can access it anywhere using your mobile phone, using a computer. And if you don't, if those are too advanced for you, you can start at the beginner, which is a really playful and interactive, where it shows you how to assemble using animations. It shows you how to test different components, how to do the bedboard models and so on. And in the intermediate is where you have students who want to learn more about the technical part of engineering. So it solves all those problems in a single package. And the thing is, you do not need internet to do anything at all, because like a satellite charges solar panels, and you can use it anywhere you want to use it. So it meets the education component, the training component, as well as access to resources. So I hope that.
No, you definitely have. You definitely have. We have such a rich panel right now, and I wanted to go back to you, Dr. Buje. So you mentioned that we need to understand urbanization, and space can definitely help in that field. And many people may not even think that their specific field of research is linked to space in any way. And the way you've outlined it for us, we can clearly see the connection. And especially when you mentioned how we have to borrow other satellites and try to buy time and modify whatever they're researching into what's going on with us. So I have a question, and this question is going to expand to everybody, and then after that, we'll open it up for anybody in the crowd who may have a question. Is, in an ideal world, 5 years from now, in the studies that you're in, environmental science, environment science, physics, and also engineering, if everything goes just in the ideal world, best case scenario, what you envision, what strides forward you think we would have made in the SDGs?
I think that there will be tremendous strides, because achievement of the SDGs relies a lot on information. If you don't know how poor people are, then you cannot get them out of poverty. If you don't know what is making them poor, then how are you solving the problem? If you're looking at climate change, for instance, a lot has been talked about climate change, but we end up consuming the information that we are given. So if you're told that Kenya is X net polluter, you accept, because you don't have a satellite to verify. At the same time, if you're told that your urbanization process is unsustainable, you have no method of verification. If we are able to enhance our abilities in space technology, and specifically in the field of the built environment and development of sustainable neighborhoods, observation becomes a very critical thing. And why is this important? We have always urbanized, but we have never clearly understood the trends of those urbanizations. At the same time, our urbanization process has always eliminated natural components. If you look at what I shared about the city, we did a similar study that looked at the transition between or from the natural environment to the built environment. And we saw that as we urbanized more, we got rid of our natural environment. And that started the challenges of environmental sustainability, because nature has a way of sorting out itself. If you introduce the human hand in a way that is not sustainable, then nature has to self-correct. And part of that self-correction is what is emerging as floods, is what is emerging as extreme heats, is what is emerging as extreme cold waves. So how best can we do this? If you're in space, you can very clearly observe what is happening on Earth. The historical perspective becomes very critical in understanding where is the change happening and at what rate is it happening. At the same time, you're also able to observe climatic parameters such as precipitation, such as temperature, so that you know that as we are clearing this forest, the temperature is changing in this particular manner. Therefore, then, there must be a correlation between the two. So action requires that. So to summarize, my response to your question is that in an ideal situation, if everything was to be done appropriately, and it does not require a lot, it only requires adherence to nature-based solutions. And the best place to observe those nature-based solutions is from space.
Thank you very much. So maybe I didn't give a bit of history about why we are studying astrophysics actually. So we are part of a group of an organization that is called the SKA, the Square Kilometer Array. The Square Kilometer Array is going to be the largest telescope in the Southern Hemisphere. Actually, it's maybe the largest science facility on Earth on completion. So there are two SKA projects that are currently running concurrently. There's one that is in South Africa, and there's one that is in Australia. Kenya is part of the African Square Kilometer Array Partnership. So we are a partner, Ghana is a partner, Botswana is a partner, Madagascar is a partner. And South Africa has been managing this for a long time now. And I think SKA organization observatory may take over soon. So one of the telescopes or the nodes should be built in Kenya. Now, South Africa or SKA could decide to buy a piece of land in Kenya or agree with the government, have a place, have their telescope and manage it remotely. But I think they decided that to share technology and transfer it, they train Kenyans all the way from undergraduate to postgraduate level so that they participate in the building of the telescope, and they are going to have some prototypes very soon, and then later in the running of the telescopes. So what I think that ideally in 5 years, strictly speaking about astrophysics, there is a possibility that, and there are spin-offs, before I go to that, there are spin-offs. There are hands-on technical skills that are learned in the process, just like you saw what we were doing, and even programming skills. And I just want to mention one project that I wasn't involved in, but I saw. It was called NASA Nano Satellite Project by a team at TUK, the space science team at TUK. It was sponsored by KSA, which is represented here. And the students designed and started from very rudimentary levels, basic levels, all the way to higher levels, which means they learned the basic skills that normally was not taught during our time in school. Some of us were taught programming on chalkboard. Nowadays, they do it. So I think there is a lot of progress that is going on. And if this continues in the few years that are coming, we are going to have a technologically conversant group of young people. Thank you very much.
Okay, so I think I'll divide my discussion into two categories. One is connectivity and accessibility. The second one is access to space facilities. So I think I'll start with the second one. So Kenya is, as you all know, Kenya is on prime real estate when it comes to spaceport, the spaceport arena. Just by being on the equator, we get a velocity boost of around 1,450 kilometers per hour, which can make a fuel difference of almost 10%. So you can launch rockets at a much cheaper price than any other country in the world because the Earth spins faster on the equator, you get more centrifugal force. So that's why if you look at, for example, Kenya's history, the Italians have built the Ungana Space Center in Kenya. Part of our Maritime Space mission is also to find out the feasibility, because currently there's very good data to look at, potential for spaceports in Africa. And almost everything we build will usually launch from outside Africa. So having a spaceport in Africa will not only be far more economically competitive than most other regions in the world, it's also going to be much more helpful to the local population in terms of engineering and technology transfer. So that's the first part, how to get there. And that's why we're working on a lot of proposals and partners on how to build a spaceport on multiple sites in Kenya. We've done the mathematical data, we've done the analysis, and currently we're at the final stage of doing that, presenting this data to the relevant stakeholders. And the second part is the usefulness of satellites in our lives. I think everybody has talked about how important satellites are in our daily lives. As long as you have a smartphone, as long as you have any device, our focus primarily in that subsector is mobile backhaul. A lot of you have used M-Pesa, you use your mobile phones for calling, for conversations and so on. But what people don't know is that the cell phone towers that exist around Africa and Kenya, it is because of the expansiveness, and since most of the population, almost 70% of the population in Kenya is rural, it's very hard and unprofitable to connect those cell phone towers via fiber optics. But satellites can do that at 30% of the cost. So it's an enormous cost. These are, whenever you transact money on M-Pesa, part of that money goes to international satellite companies. Whenever you browse on your phone and use internet, a good part of what you send actually goes to foreign companies. It leads to loss of cash. Your data is not controlled by you, which means that you cannot really trust the security of it. And a lot of it's not customized for your solution, because when these countries launch satellites, they launch it to cover their own region, geographical areas. Africa is really an afterthought. So if we have our own satellite constellation, we can easily optimize these solutions, not just for mobile. You've seen what mobile money has done to can basically transform the entire economy. You can transform entire sectors that were unthought of. Places that were initially not financially viable enough to connect to their internet and give those people accessibility to education and information will become easily viable because it's so cheap to cover a geographical area within Northern Kenya using a single satellite. It's much cheaper than conventional fiber optics and communication methods. So that's why we've also fine-tuned our mission at Humanitech to provide a constellation that will provide mobile backhaul services and cover the African continent. So, yeah.
No, that's amazing. If I'm understanding correctly, if we do local, we not only get scientific data that's more focused on what we want, the cost will go down, better services, and we know the companies are local. I think that's a great deal, and we should push forward and keep going. I'm pretty sure that all the internet breakdown that we had today would not be the case if we had those local satellites up. So I want to open the floor to anybody who may have any questions and want to join in on the conversation at this point. Oh, we have someone in the top.
I think it can be had. Please mention okay, first of all, let me thank you for the good contribution that you made for today's conference. My question is, you've mentioned that you require very specific data, but especially coming from you're coming from a very different field from mine. I would be interested to know what exact data, what specific data, which is it that you're looking for, so that if I'm going to make for you a satellite, I know what I'm doing. So I have as the input.
I don't know whether we wait for the others first, then respond.
Thank you, panelists, for your very insightful presentations. My name is Jack Matara from the Kenya Space Agency. So, as in, everything that you're talking about is something that is so close to, our hearts, our mandate, and what we're supposed to do. So, maybe there's a question for each one of you, apart from the moderator. So, for yourself, as in Abuja, if I got it right, you talked about there was limited access to data, and especially in that sphere. I think I cleared school like over 10 years ago, and even when we were still in school, we had open source data access and all that. So I don't know how your experience has been when it comes to networking with industry professionals, not just in your built environment, but across all of them, so that you can be able to share ideas and also be able to, to learn of the trends of what is taking place and what tools you can use and what kind of new professionals you can incorporate in your project. But it's quite impressive what you're doing, especially with SDGs and climate change. And then for Professor, good work you're doing at TUC, and space and astronomy is something that we're trying to catch up with, especially as Kenya and maybe Africa. At the moment, it's not a priority for us because we first of all need to eat. we need to live and survive the disasters and everything. So we tend to focus more on Earth observation data, its uses, and how we can be able to use that. It's a low-hanging fruit for us. So for us to be able to embrace space science, astronomy, and astrophysics, we need to be able to make a case for how the study you're doing, the data that you're collecting, is impacting the common person, because all that you're doing is to improve the level of life or the standard of living of every human being. It's something that we're trying to do, like, how do we plug in, how do we compete, how do we put space science and astronomy and astrophysics to compete against other priorities, especially in the national, at the national level, even for the fiscal allocation and all those kind of things. So maybe around there. And on the other one, Omarijet, right? Yeah, we've had a lot of conversation. And of course, education and outreach is something that is so close to our heart, because we need to develop that capacity, our national space capability, to be able to do all these things, astronomy. We need those professionals. And it's impressive what you're doing. And you've heard from TUC that the university is also doing the same by getting grants from KSA. So it's just to probably know who are some of the partners that you're working with on this, and your platform that you're using for those CubeSats. How accessible is it to students across the country at all levels, and how easy is it to get probably the materials? Because I know there's a lot of 3D printing there, a lot of wasn't that kind of spectrum, so that they're not limited to the few privileged ones. And what is your vision, especially now, to reach all those? I think that is all I had. Sorry for taking too long.
Thank you. So I jotted some notes from everybody's questions. So so the first one was geared towards you, Dr. Abuja. Was that conversation starting right now? So what data would you need if we're making the satellites for you right now with the sensors on it? What data do you need?
All right, thank you very much. I think I'll tackle both questions. So specifics to the built environment. One is there is data on land cover. And the biggest challenge, which I will also respond to what you was asking, is the level of resolution. The data that is mostly readily available in open source, in most cases you get, I think, about 30-meter resolution. But you can realize that that is ideal when you're dealing with large-scale spaces. But if you're going to start reducing it to medium scale and small scale, you need higher data resolution. And I remember when we were actually doing part of the research that I was just showing you on the screen, we were given a cost of roughly about 1.4 million shillings to buy the data. And this is data for only 2 epochs. And you're doing a historical analysis over a 30-year period. So you can imagine if you need 30 epochs, you're going to spend more than 30 million shillings. And listening to the conversations that are happening now, I understand why that cost was that much. Back then I did, because I was wondering, okay, there's a satellite. You acquired this information and you can sell it to me and several other people. So why is it so expensive for me? But if the satellites are owned by other people, then of course they'll do the pricing the way they want. And that also starts pushing the need for us to have local information. Now, I talked about land cover. We also need a very significant climatic data. Here we are talking about precipitation. We are talking about temperature. If we are able to, and this is where my knowledge is limited on what is possible from the satellite realm. If we are able to get comprehensive climatic data, Earth surface temperatures, air temperature, wind speeds, precipitation, and all that, if that is possible, then we start getting very, very detailed research outputs and very, very specific methodologies and approaches to dealing with, for example, climate change mitigation and adaptation. Thank you.
Just a quick little check-in of how we're doing on time. Okay, please continue.
Thank you very much for your questions. And I I just want to mention them in different categories. I'll say skills and technology. When it talks about resolution, I understand it because I do image synthesis. So the kind of cameras that they have, we use them. It's similar. So the technology is similar. And when I was at Leeds, there was a postdoc who was there. He was working on computation. And he designed the rail track, the timetable for Leeds town. He was an astronomer. So the skills that are there can be used. Actually, astronomy stretches it because we're limited. The object, you can't change it, and so you have to look for other ways of solving it. We had problems with resolution that it has a problem with because of distant objects. We went into something called interferometry. It's a technology that they may use in future, maybe observing one object with 3 or 4 different cameras, and then try and synthesize the image using some mathematical Fourier transform, actually. So these skills can be, the skills from astronomy can be very powerful in the economy. 2, their research shows, I don't know who say it, but research shows that there are 2 areas of science that really motivate young people. It's either dinosaurs or astronomy. So if you want to motivate people in the area of STEM, astronomy is a very powerful way of motivating people. 3rd, I would say most of us in this country are very religious. And astronomy, I'm not saying it explains the Bible, but it can help you build your faith beyond believing. So even for faith alone, astronomy is very powerful. Thank you very much.
I really thank you for that question. So the way we thought about accessibility, we thought about it first as an open source platform. So we have a GitHub where anybody can access everything from the circuit board designs to also the 3D printed designs, the mechanical designs, and as well as all the documentation for the code. So we've been documenting the process and open sourcing it as we move. We've been documenting the changes so that even if you do not have our edit and you have the resources anywhere in the world, you have a Pi4B, you have a 3D printer, you can replicate it and use it wherever you are. We've also thought of how do we make the educational material more accessible, because we're looking for, we settled on Colibri, which has been very successful in Uganda, in South America, and other places. It's basically an open source server where once you install the server software, whether you have a phone or a computer or anything, whenever it's connected to the internet, it automatically downloads all the updated course content, and you can access it off-grid wherever you are. So it enables anyone from the most rudimentary, even a smart fridge, can be able to access all the learning materials on the edge. So we built upon Colibri's open source platform to ensure that the materials that are on, the material and learning resources that are on the edge are available in your online as well as offline, as long as you have an edge. As for our partners, we've really drawn inspiration from the Telcom with what they've been able to do, connecting very remote African countries with their inter-African network, and we built upon a lot of their ideas on how we can also do the same. The problems that they faced in other African countries, what problems they faced in Malawi, Zambia, and so on, and the difficulties in access to education, and we're trying to connect schools in those regions, as well as other partners. I think we'll be talking to KSA also as well, and we've also had Gearbox as our partners in manufacturing the PCBs locally, because we could have had an option of manufacturing them in China, but we thought, let's try and do everything locally. Let's show that it can be done here. As well as a lot of the materials, the screws, and so on were procured locally. Although it made it much more easier to assemble, we removed a lot of screws in that we just fit it together like a puzzle. So you do not need any special tools, you do not need any soldering kit, you do not need anything you just plug in things into pots and they work. So we thought we've been iterating throughout the process to make it as seamless and as easy as possible, that somebody with just their hands and a screwdriver can put it together. You do not need any special assembly tools. So I hope I've answered the three points that you requested.
Definitely. Thank you. Please give it up for our panelists. This was really... Yes, I thoroughly enjoyed listening to the conversation, and it really, the roundtable talk, I think we made some advancements here with next steps of what we're gonna do to move towards achieving those SDGs. So I thoroughly enjoyed it myself, so thank you for the great panel.
Thank you so much. You are absolutely amazing. All three of you, I mean, you think about your accomplishments and your minds and so on. We're very grateful to be in your presence. I'm asking you to stay right where you are because we have a very special moment and a very special celebration. Dr. Claire Nelson, the ideation expert and the convener of this, when she was coming here to Nairobi, she said she wanted to come in early so she would be able to spend her birthday here. Many years ago, I think it had been about 40 years ago, she brought her mother here for her mother's birthday. Her mother's birthday is the 4th of July, hers is the 5th of July. And so she thought she wanted to celebrate her birthday here. So far we've had 3 celebrations of her birthday. The night of her birthday, her husband and I and her went to dinner at Handy, and they celebrated her. Just by knowing it was her birthday, they celebrated her. And then we went to Caribbean restaurant, Josephine Barbecue, and the owner of the restaurant had a saxophonist serenade her with happy birthday, and it was just an amazing experience. And then on Sunday, she was invited to brunch by the CEO of Hemingway, that fabulous hotel in Nairobi. And at the end of brunch, they came out with one of the most delightful birthday cakes, decorated in the Jamaican flag with gold dust on it. Happy birthday, Claire. And the saxophonist came over and celebrated her happy birthday. Now it was just about 6 of us at brunch. And so the rest of the cake, we decided to take it here and invite you to celebrate with her birthday and to participate in the cake that was provided. So at this point, I would like to ask my sister and friend, Dr. Claire Nelson, to join me up here. Oh, it has to, where's the photographer? Can you all come up, please, to partake? Please.
I can do the sounding too.
Come on up, folks. Thank you.
You're such a good dancer. Wow.
Yes, she is.
She's pretty.
She's a poet, she's a singer, she's a dancer, she's an actress.
Wow, she's gifted. Yes. Thank you. What a way to do it.
The flag is edible and so is the gold. Caleb, you have to get the flag.
If there's nowhere in the world you can go and not meet up at least one Jamaican, well, I was the first Jamaican on the moon. I first came up in 2032 as part of the initial set of citizen cosmonauts that came up to Lunarville to set up the space heritage.
It's lagging.
So the plate's finished before the plate finished.
Try again.
You want flag? Is everybody on the plate's finished or 2 plates left? You got?
No.
You gave away yours?
Yeah.
We need more plates.
Yeah.
More plates. We need more plates. How many more? How many persons haven't gotten cake? 1, 2, 3, 4, 5, 6, 7, 8. We need more plates.
Yes.
More music, please, Mr. Music. Really? Go ahead. Tell her. Go ahead. 65. She needs to 65. A very young 65. The last one. Has everybody got cake? You, Dr. Marcy? No. Anyone else? Last year, he was not here.
The camera was supposed to, was it full or it still work when you were taking it?
Such a nice idea.
And to help plan for the Space Goodwill Games. Now, how I got here is a long story, but I'm going to give it a short version. So, back in 20 years ago,
Part 3 of the celebration.
doing work on how to share space, and I came across this lunar embassy. It was a company owned by this American guy who claimed that he owned the moon. And he was selling titles to an acre at $19.99. So I was quite tickled, intrigued, and I decided it'd be nice to say I own a piece of the moon. Well, I went online to pay for it and found out that they were also looking for representatives from the lunar embassy. And I was really intrigued. I mean, I had always wanted to be an ambassador. But when I sent the emails back and forth, to and fro, the answer came back. Well, you gotta pay us $10,000 and guarantee a certain number of sales per month. I'm like, huh? Are they for real? They're really trying to sell the moon? So I really started taking this research seriously. Looked up space sustainability, space settlement, space law, space health, and finding out about SpaceX, YZ, Galactica, Mr. Musk, and the Three Musketeers. And it seems as if all they're trying to do is gather up all the mineral wealth, plunder this galaxy, and do space tourism and make zillions of dollars. And I am getting really vexed as I'm thinking, what about the rest of us? Now, one thing you need to know, when a Jamaican gets vexed, watch out, we are going to do something about the source of our vexation. So I decided right then and there that I was going to work to ensure that regular people, the 99% of people, had access and rights to space. Then I really started to dream big, and I thought, a matter of fact, I want to make sure that Jamaica takes the lead in pushing for a space goodwill games. Yes, that's right, and a space heritage site too at that. Talk about dreaming. Friends, I had no idea what I was about. I had nobody in the space movement. I wasn't involved in any organizations that had anything to do with space, but that was not going to stop me. Who knows what would happen? I set off because I knew people who knew people. My first person was the ambassador of Jamaica to the United Nations. So, this is me. Ambassador, how is it that you members of the small island development states don't have a space program? It's like, you know, I don't know what sense that would make. We don't have any real purpose in space. Ambassador, what are you talking about? Do you realize that if a piece of space debris was to fall from a shuttle, a spaceship or something, it could drop on one of the islands, obliterate half of it and half the population? You guys have insurance for that? Clear? You know, let me think about that. You may have a point there. Yes, Ambassador. And while you're thinking, try and see if you can get Jamaica to take the lead in making them have a space goodwill games. Okay, Claire, I'll give it some thought. The seed was planted. Next step, I have to create a movement. So I joined the Union of Concerned Scientists, and I joined this global grassroots organization called Civicus. It has hundreds and thousands of people around the world, and their main mission is to ensure that citizens have a right to a democracy. Once I get in, I start to infiltrate the leadership. And when I get to the right people, I start to promote that they need to take on the issue of space sustainability, because they ought to understand with climate change and data and communications, Earth sustainability and space sustainability went side by side. They had to do both together. Well, it worked, and by 2020, we had created a new organization with offshoots of each of these, and this new group was called the United Planetary Society to Achieve the Rights to a Shared Space, the Upstarts. And over the years, the Upstarts began advocating and lobbying and writing and researching and promoting, and we became a fixture on the NGO scene in the space movement. Now, by 2025, things were getting really hot. The countries were getting frazzled. China was about to land on the dark side of the moon. Mars was on, NASA rather, was on target for Mars. And the Europeans also were on target for the moon. But the issue was the rights to the minerals. So things were tense. It looked like a Star Wars was about to blow. We were nervous, Rick. When we landed up on Space Week, we made a beeline for the Nigerian space delegation. There's a guy there called Comfort Goodluck who had become our friend. So I'm like, Comfort, I know that you Nigerians are only a small fry in the space game, but you still are the largest, most populous African country. I think you ought to take the leadership in ensuring that these people don't take us into a Star Wars. You ought to take the leadership in pushing that the UN declares the decade 31 to 40 to be a decade for peaceful exploration of space. Comfort, you can do it. Go for it. I know the Jamaicans and the small island states are behind you. You're going to have the votes you need to get it done. He was like, my sister, I think we have a plan. So that was done. Things were moving, and by 2028, the UN declared the decade of peaceful space exploration. And the IOC, the Olympic people, also were now on board with the idea of the Goodwill Games. But the issue is, who is going to fund it? So I pulled my last card, the private sector. I contacted my friends who were bigwigs at Google and Intel and Facebook and all of them. And with each one, I made a call and I said something like this. You know, it's really sad that your reputation is going to tank because the public perception is that you guys are behaving like rapacious, plundering pirates and buccaneers, pillaging the whole heritage and commonwealth of humanity. You have to do something better. Your corporate social responsibility with respect to space has to be more robust. You need to support the idea for Space Goodwill Games. You need to jump on board with the idea for Citizen Cosmonaut Program. And they bought it, hook, line, and sinker. So my 70th birthday, and 70 was the new 50, I got the present of my life, the announcement of the Citizen Cosmonaut Corps. Hundreds and thousands of people from the world applied. And my friends compelled me to apply because they said I had to lead by example. Now, let me tell you, I had no interest in ever going to space. I was happy being an earthbound Trekkie. Yes, the truth is, I'm a weak-kneed, lily-livered, white-bellied flyer. The minute a plane starts to shudder, I'm holding onto the arm of the person next to me, and I'm saying my Hail Marys, and I'm not even Catholic.
So that is me performing in 2016. The first edition of Moon Runnings that was written and performed at the Merge Festival of the Future at Arizona State University. That was the first time I conceptualized my entry into space. It was totally a fictional story in 2016. In 2018 was the launch of the Caribbean Space Society. By 2019, I said, let me go global, let me incorporate Africa. And the Space Futures Forum was created to be a place for that ACP grouping to kind of find each other in the United States, in the UK, around the world, and begin to create a community of practice that could engage people, quote unquote, back home. And here we are, 4 years later. So for those young people who are saying it can't be done, let me tell you, it can be done. Let's focus again on the vision. What was the vision for me? To ensure, as the upstarts of my fictional organization is called United Planetary Society to assure the rights to space. And so when you hear the Dr. Proctor talk about a Jedi space, justice, equity, diversity and inclusion, it's always been about creating an inclusive space. And this is a facility that I think will begin to implement the dream that has now really become a part of my reality. So when I ask you to write a future story or to create a future's headline, it's not an idle exercise. So I ask you please to be very intentional, to make sure it's plausible, make sure it's aspirational, because you might find yourself like me, living the very story that you wrote, because I'm doing that today. So let's move on to the closing session.
Okay. Tomorrow, it has been announced that there's going to be some organized protests at various places in Nairobi. Public transportation has been called on to support the protest, so has private transportation. I just had a discussion with Dr. Mashiri, and he was very, he gave us some really good advice. He said, we're already set up here, so let us keep the program as is. We have all our telecommunications, internet here. People who are unable to come for whatever reason could log in online, and we still have an online community with the speakers. He said that by maybe 4 or 5 o'clock in the evening, things will clear up a bit, and even if it's not cleared up then, those of us who are here could hang on for maybe another hour and then head into Nairobi. So that's the least disruptive of all the options that we have available. So I think that's what we should do. What do you think?
I'm fine with that. Okay. What has that road as well? I mean,
yes.
The highways that we have to come back.
Right, that's what he said. There is some road that will take us, yeah. So we're good to go for tomorrow. The program remains the same. And if you're not physically present, please just register on Hopin and come in on the program. All right? So you're good then, Zinga. All right, who is moderating? You are, sir. Okay.
All right, welcome everybody to our last session of the day. We're joined by a few different people that are in the fields of engineering. And I'd like to introduce our panelists. We have some that are backstage as well, and I can see they're joining us. We have Cheyenne Powell has joined us, as well as Professor Engineer Samir Hamir. And we also have two live here. We have both. We have, yes, we were just talking, we have Mr. Byron here that's helping us in this conversation, as well as we have Dr. Simon Njuri. So all of our panelists will introduce themselves a bit more with what they're going to be presenting. I think we can start off with some of ours that are backstage. Professor Engineer Samir Hamir, would you like to begin us off, please?
Yes, please. Thank you very much for giving me an opportunity. My name is Engineer Professor Samir Hamir. I'm the Director of the School of Aerospace and Vehicle Engineering at the Technical University of Kenya. We are a school of aerospace, and we have 4 departments: Department of Railways and Automotive, and actually I skipped the most important one, Department of Aeronautical and Aircraft Engineering, and then Department of Railways and Automotive, Department of Offshore and Marine, and Department of Space Systems and Engineering. So my research interests are mostly in helicopter aeromechanics, and what I wanted to present today was on the importance of industry linkages in our aerospace engineering programs. I believe JQuat is also following suit to launch an aerospace program early this September, I believe, if I'm not mistaken. I do serve JQuat Pausti on a regular basis, but I think aerospace is a very critical field and a highly regulated field. So that was my punchline of the talk today. So can I continue? And maybe I might have missed the spring altogether.
Yes, you can. Yes,
can I make my
continue.
presentation is going to be in terms of. Yes, I can continue.
Yes, you may.
Okay, thank you very much. I really appreciate. So let me set the stage. For instance, us at the Technical University of Kenya, we have a 5-year Bachelor of Engineering program. And the crux of the engineering program is an aeronautical engineering program. And I will define aeronautical in a bit. But what I'm trying to focus on is that what a pilot does 3 things: aviate, navigate, and communicate. And those 3 components or constituencies are part of the embodiment of an engineering program, of an aeronautical engineering program. And industry is at its epicenter. If you look at Airbus, you look at Boeing, and you look at the universities that are within their vicinities in those countries, even Rolls-Royce in the UK or the North American Rolls-Royce, you will see that the lecturers, 80% of the lecturers are tied to industry. So they have the knowledge of the environment in which the aircraft resides or is domiciled. And that is a hangar. And understanding a hangar where all the workshops, even if you need to repair a tire, all the workshops are right. That's where the homage or where practical research is conducted in the field. So it is really important for us in Africa, especially in East Africa, myself, from across the border, from being a Tanzanian. One of the key things in our countries is our programs are very theoretical based, so that we don't produce practitioners in engineering. Engineering is hinged on design. That is the fundamental crux of it. It draws first blood through design. And taking into context what we have done at the Technical University of Kenya, we teach our students in the airport. How is that done? Through collaboration with aviation companies, through and taking our students there for practical visits, for field visits, so that they get a feel of the aircraft, the turbo machinery aspects of the aircraft engine, how it is split, what goes into the standards and regulations, and in context, what defines aerospace to be a highly regulated field. So the importance of industry is key, the local industry, and there's also the international industry. Of course, of which General Electric was able to donate us a Boeing 767 live turbofan engine in our labs for demonstration and teaching purposes, and for being able for our technical staff to be able to open up the engine in the event of failure and be able to return it back based on OEM or original equipment manufacturer tolerances and whatnot. So industry must be actualized. The practicum components must be realized. I know universities go through financial crunches, but I feel collaboration is key here, that we don't work in silos. And in order for us to grow, we must build partnerships with industry. I think that is what makes an all-rounded engineer. Now, I'm not going to give you a very long-winded speech, but what I'm going to do is going to explain you what aeronautical engineering is. Of course, aeronautical, from what it sounds, this is to do with the aircraft, the terrestrial aircraft that we are familiar with, like the helicopters and the fixed wing or rotor wing aircraft categorically. But if we look at aeronautical, it covers the aerodrome operations, the airport operations, the engineering bits, and all that. And to a larger extent, aeronautical engineering employs what is called traditional design. Traditional design has its flaws in engineering. One of the drawbacks is it does a uneven, fragmented tackling of the major disciplines in aerospace. So one would probably start with propulsion, and then, or maybe aerodynamics, and then move on to propulsion, and then go on to structures to understand the layout of the aerospace vehicle, and then finally stability and control. The second thing, a lot of historical data there's a lot of historical data reliance. The third thing, so it's not a physics-based approach. The third step is it is highly serial in nature. That means you are as strong as the weakest link in the chain. So what aerospace engineering brings to the table now, it's not just a fusion of the atmosphere level and the above atmosphere level. It is actually employing advanced engineering approaches, which uses stochastic and physics-based, like codes for aerothermodynamics codes. So you're using predictive physics-based methodologies. You are also using probabilistic methods, and that advanced design does not mean that it is better than traditional design. It's that advanced design evolved from traditional design. And aerospace, the term aerospace in general, uses what we call a system of systems approach. It means if you have a huge an entity, it can be broken down into subcomponents, and each subcomponent can be operationalized independently and can be managed independently. So what I'm lobbying for today, and in most of our institutions that offer aerospace engineering, being the trendsetter in Kenya, for looking at Kenya Vision 2030, how do we avoid producing theoreticians where you use dictatorial teaching approaches or teaching didactics, but a more what you call participatory approach is required in engineering, where the student requires engagement, and it's also based on project-based delivery. This is the newest way of teaching engineering, like what MIT does, for example, citing an example in that context. So for my case, I vouch that in order to make aerospace engineering a successful endeavor, we not only need industry collaboration, but we also need domestic collaboration, because we have universities in Kenya, JKUAT, Kenyatta University. I have been privileged to be serving on all those three. And as a master supervisor or a part-time lecturer teaching advanced applied computational fluid dynamics and whatnot. But what is so inspiring about that is that we were able to write a grant proposal together, though we are still awaiting news on whether we won or not. But it's not really about winning. It's about the fact that we were able to collaborate, knock our heads together, and work together as a team, as opposed to saying, okay, TUK is a giant in aeronautical, the only school of aerospace. JKUAT is still a young kid on the block. But we work together so that even if somebody is miles apart or miles or inches apart, we work together as a team for the benefit of our students. And I will end with one thing. Competition is a driving force, while collaboration is an enabler. And we all must remember, those of us who are in academics and research, that we are here because of our students. So there should not be competition between universities, but more so a merger, a domesticated partnership that trickles into the quadruple helix articulation of government, academia, industry, and the impact of that endeavor, say in a community or a technological component. So with that said, I would like to say thank you very much for giving me an opportunity. I hope I was not too long-winded, but that was something that was close to heart for me, and I really appreciate it. Thank you.
Thank you for that. Thank you for that message, Ms. Samir. Can we give her a round of applause? And as you were talking, I really connected with how you were talking about the data reliance as well as the serial dependency. And hopefully we get a chance to discuss a little bit further on that practical research that you were mentioning about in the panel when we get to it. So next up, we'd like to also have Cheyenne Powell go ahead and present and introduce herself.
Okay, thank you. Hi, everyone. And I'd like to thank Dr. Nelson for the conference. It's been really informative, and I'm hoping that my work, I'd like to contribute to the society, to the community. So I'm going to tell you a bit about myself and a bit about my work. So my name is Cheyenne Powell. I'm a PhD researcher from Jamaica, studying at the University of Strathclyde in Glasgow, Scotland. I am researching on explainable artificial intelligence for robust and explainable mission planning and scheduling. So before I get into the details of my research, I am a graduate at Cranfield University, where I studied astronautics and space engineering, with a project where I developed a self-sustainable system for microalgae in deep space environments. While I was doing my master's, I studied in Japan molecular robotics as well. Additionally, I worked as a full-time electrical controls engineer, as a project manager, where I oversaw projects internationally across the UK, Japan, China, Mexico, the US, and yes, I worked in Jamaica as well as an engineer. So prior to my master's, I completed my bachelor's degree in electronics and electrical engineering in Jamaica at the University of Technology. So I transitioned from manufacturing industry to develop my career in the space sector by doing PhD right now, and I have currently over 7 years of engineering experience globally, and I will be an entrepreneur in the space sector, contributing, and you're going to see a bit more about what I'm working on. So I will start with my presentation. Just a second, I'm just getting my screen up. Let me know if you can see it.
Yes, we can see it.
Okay, thank you. So I'll be presenting to you on explainable artificial intelligence for mission planning and scheduling for Earth observation missions. And the focus of this will be the applications of XAI, which is explainable artificial intelligence for floods and natural disaster monitoring. So I'll start with the autonomous scheduling and planning. So you might want to ask, what is planning? What is scheduling? So it's really just the activities based on the mission, what you'd like to achieve. And it's like activities or actions that the satellite would execute during its orbit. And scheduling is where you assign a timestamp to each of these actions. That's just it in a nutshell. And here's an example of what schedule would look like. And regarding the autonomous scheduling, the red represents this is what a ground station operator would create, and this is what the environmental conditions would be that the ground station operator used. And the output would be what the scheduler generated using the human input and the environmental conditions autonomously on board. So for flood monitoring cases, say, well, you have a constellation of satellites. Satellite detects an anomaly in the ocean, and it then relays a message to the following satellite, which is, it could be a few minutes behind, depending on the orbit, depending on the type of satellite. In this case, this example was an image of the Fiji Islands due to a storm approaching the MVSAT mission. Now, this is just a really simple image. Of course, it'll be more detailed, more graphical, but this is a simple presentation, so I won't go into much details here. So for the Fiji mission, when there's an anomaly, it will be communicated to the following satellite, and this is where the schedule will be updated. So the following satellite will be like, okay, I'm going to update my schedule, and I'm going to rescan this area of interest. Now, when it rescans and when it communicates, or whether or not when it updates its schedule before it rescans, it establishes communication to the ground station operator, and you'd like to know what's going on. So I'll give you an example. This is Mike. Mike is exercising. Mike is now going home. He's now home. Now wondering, what do I do now? I'm very hungry and I need to have a shower. So he's thinking, do I have a shower first then eat? Or do I eat then have a shower? So I've developed an algorithm that would apply this analogy. And what I mean by this analogy, the decision-making process that Mike has to go through before he makes this decision. So it's like a little conflict within yourself. We all go through this when we have to make decisions. And we're thinking, okay, do we do A instead of B or B instead of A? What would happen if I did this instead? So I've developed an algorithm, and it's in the form of it's in the form of argumentation. So going back to the flood scenario, that's the snippet of what argumentation would look like. So that's conflicts of the environmental conditions within the satellite, and the hardware components on board. So here's an example or case scenario that would be used for monitoring floods. In this case, what happened here was there's a receding ocean levels at the shoreline in 20 minutes. There's more sand that's visible at the shoreline, and there are high water levels in the ocean. So the satellite has detected these three things. So the following satellite in the constellation would get this message and be like, okay, I'm going to update my schedule. And then when it establishes communication with the ground station operator, you might want to ask, here's an example. Why was the schedule updated to retake this area? Now, from a human point of view, you would then say, okay, within 20 minutes, the ocean level receded, and based on the 3 points before that I mentioned, in a nutshell, it could be potentially a tsunami. So everyone needs to prepare or get everyone away from the coast. So here's just an example on how explainable artificial intelligence could be used. So that's a human explanation, as what I would say to someone. However, if it's a system, I used natural language processing. And what that is, everyone is hearing about ChatGPT. So what I did, I connected ChatGPT to my argumentation layer that analyzes everything that's going on in the schedule. And here are two outputs. And here's a simplified explanation and the non-technical explanation that requires details. So it depends on who the user is, will determine how much explanation is needed. So the simplified explanation is pretty much a summary from the human explanation. However, it also stated that in addition to the tsunami, it could also be a similar natural event. And also it suggests that water is being pulled back, which is an indication of an impending large wave. Now, if I go to the non-technical explanation, it's really wordy. I'm not going to read everything. I'm just going to go through the highlighted points. It detected a coastal phenomenon such as a tidal wave or storm surge. And additionally, the significant shift in sea level, and you have a caused by an incoming wave. And in summary, to better understand and monitor this situation. So that's someone who's non-technical, is trying to understand why did it reschedule. The satellite would then provide valuable information to meteorologists and other scientists. So for someone who's not technical, they would say, okay, this data would be useful for scientists. So that's an example on how different, the settings will vary based on the explanations required. And yeah, that summarizes my presentation. I try to make it non-technical and not get into too many details. So thank you. Any questions?
Thank you, Cheyenne. I'm sure we're going to have a few questions coming up. Hopefully you can stay with us to have that panel. I mean, as you were talking, the idea of those AI algorithms to make decisions and the fact that it will share information based on the user, this saves time and can also save lives, especially when time is a factor. So hopefully we can have more discussion a little bit later with you. And I'd like to bring some of our panelists, and we just had another panelist join us here, and this is Dr. Sonia Jita. So I would like to begin our discussion, if it's okay with you, with Mr. Brian Anagwe.
Good afternoon, good morning. My name is Byron Anagwe. I'm from an entity referred to as ESRI Eastern Africa. But by profession, I'm in satellite positioning. And I like the discussions that have been going on since yesterday, and today was more technical. And personally, I've been a little bit disillusioned with the technology because there's two groups of people we're forgetting. Group number one is the policymakers. How do we communicate with policymakers who are nearly equivalent to 10-year-olds? What language do we use? What's their take-home message from this? Then there's the other group, the communities that are impacted on all these things that we're doing in terms of greening processes, in terms of the technologies we're applying, in terms of the information that comes from satellite observation. Today, I think there is more of an outburst of information. So how do we package this and make this much, much more usable, especially in light of the SDGs, the national agendas, like Kenya at the moment is on digitalization and the Big Four agenda. Webmaster, please, could you get for me slide the link number 1? So what we're doing towards addressing this is that we are developing robust information systems. I'm happy mention has been made here about artificial intelligence that gives information that is coming from satellite technology, from Earth observation, from space measurements into a way that it can be useful for all of us here and the communities that we come from that are impacted. Farmers are not interested to hear things about vegetation indexes. They want to know when do they plant, want to know when do they harvest, what type of crops do they need to grow. On the other hand, decision makers want to know what they need to do within the aspects of the little budgets that they have. Case in point, what you're looking at the moment is marine protected areas all along the Indian Ocean. Space measurements were mentioned here about space weather. How are they affecting what is happening in the large water bodies? We don't have a choice of who our decision makers become, especially politicians. And I know many of you don't vote, which is also one of the problems. So we don't have a choice who's made you minister. We don't have a choice who's made you administrator. But as experts, what is the language we take to them? How do we encourage them? How do we give them information that they can use? If we use information that's coming from satellites, for instance, put it into a platform like what I've just depicted here, and show numbers. With politicians, policymakers, you show numbers. You show 30,000 people will be affected. They start thinking about number of voters. So we have to change our perspectives away from the science to other aspects. Because of interest of time, I have given out some links. You can peruse those. Could you open link number 3? So with information coming from space, we can be able to come up with metrics that will be very useful to decision makers like ourselves, decision makers in government, to private sector who I am representing. Private sector want to see where there were changes. Space brings new opportunities, especially if you look at the strategic plan of most African space agencies. There is a part of space economy which we can start harnessing immediately. One of the ways we can do this, number 3, please. That's number 5. So one of the ways we can do this is through agriculture. We can be able to make food that is high quality and edible in space, because in space you'll be having your whole orange is just a small pea. That's an area we can harness. We can harness looking at new development. South African space market has been because of new equipment. So we can be able to run these metrics. And for private sector, for investors, we are able to look at information that is coming from space, similar to what is on the screen, and be able to tell what is the high quality oranges we can get, what is the high quality of maize. And this is all based on space technology. I want to disagree with the previous speakers of the same session that data today at high resolution is available. We have Sentinel from 10 meters, which is more than enough. We can be saying we want higher quality data, but do we have the processing capabilities? Because one high resolution image at a very small 10 by 10 meter resolution is 2.4 gigabytes. At 2.4 gigabytes, Windows can't even open that. Windows at 2 gigabytes will crash. So what do we need to do? We need to first harness what we have, see how to make it usable, and then see how to apply it, change communities, increase downstream activities that bring value into the whole value chain of the space technology. Chair, I submit.
Thank you for those points. As we were listening to you mention a lot about agriculture and harnessing what we already have on ground, and I think the conversation we're going to have a little bit later is really going to tie a lot of these things together. Our next presenter, I would like to invite Dr. Simon Njuru to discuss a little bit about his background and field.
Good evening, all of you. My name is Jerome Magene. I am a lecturer at Jomo Kenyatta in the Department of Electrical and Electronics Engineering. with a bias in telecommunication. On the matter space, was the project lead for the 1U. I was the project lead for the 1U nano satellite, which was done by Jomo Kenyatta, successfully, I would say that. And I'm also offering mentorship to support students who are in the Nakuja project. I think that was mentioned earlier today. And currently, I'm the one who is doing the project management for the 3U CubeSat development, which is, we call it Tafiti. Tafiti is a word which comes from research. And this Tafiti is funded by Kenya Space Agency, and it's being done by 4 universities. So University of Nairobi was given the position of the chair, Professor Mutia. Then Jomo Kenyatta was given the position of the project manager, which is the position I'm holding in that project. The other universities, we have Kenyatta University and TUK, which is the Technical University of Kenya. I think the professor who talked earlier mentioned about that ongoing project. The missions which are proposed for the Tafiti project, which is ongoing, we are at the implementation stage. We have done the design, we are now currently at the implementation stage, and the missions which are there. The first one is on urban planning, capturing data which is going to be used for urban planning. So I think Dr. Abuji, you'll benefit from that, and that is why I asked you what kind of information is required. We're also considering possibility of being able to do carbon trading, where you can collect the information on the ground, on vegetation cover, and we use it for carbon trading. We are also intending to collect data on solar mapping, so that we can be able to advise those people who want to do large-scale solar harvesting on the correct positioning for their solar panel. Then the other mission will be on crop mapping, where we're able to collect information on available crops on the ground, so that we are able to predict the possibility of harvest, and some of those farmers that are more speculative can be able to benefit from information, knowing that at this particular level we don't have this crop available on the ground, and therefore they can consider having that one put in place. So for today's, I'm going to talk about the 1U nanosat that we developed earlier, because it's the one which recently to today's topic, which one of the parties talking about disaster management. So this 1U nanosatellite had one of the mission being disaster management. And what I would say about it is that the project was student driven. Actually, my position was more of to guide them, or oversee the processing of the project. The whole work was developed by the student, or rather the whole project was carried out by the student. And as it was mentioned even earlier by other speakers, we concentrated on using the locally available materials and largely ensuring that students are able to obtain, learn by doing it from scratch. So we wanted them to do everything from first principles. And that way, we were able to develop a proof of concept or a prototype, which is a bench model that is now what we are using to build on to do our engineering model, which is the 3U nanosatellites. I think this one talks or touches much on SDGs number 3, 6, and 15. So let me just give you the concept of the solution that was proposed. And we are talking about disaster management. So the concept, I'm going to present it to you in 3 bits, and we are going to look at what is the satellite able to do for us before a disaster takes place. The second point is during the disaster, and my third point will be looking at what happens after the disaster. So before the disaster, we'll have the satellite launched in space, and it is expected that this satellite will be continuously monitoring environmental conditions and changes, and these are the ones which are crucial to predicting and managing disasters. So we are going to be, or rather, this particular one was expected to take factors like temperature, humidity, surface temperature, wind patterns, and ocean currents. And with that kind of information, we can be able to even do predictions of storm, we can be able to assess the possibilities of floods, and we are also able to monitor the climate changes in vulnerable locations. So the other effect of us having a satellite in space, this particular satellite in space, which was doing disaster management, is that it can give us early warning signs. So with us being able to detect the natural disasters like hurricane, cyclones, earthquakes, and floods, and this one also providing real-time data on the size or intensity, something like cyclone and hurricanes, and also the movements, then we are enabling the authority to be able to timely plan for evacuation and also be able to prepare emergency response in time and even mobilize resources. So those are the areas that are done before. Then after the disaster, the satellite is able to collect information on the situation. So we are able to pick on the extent of damages which are there. And this is going to help authorities prioritize on the response effort, and we can also be able to allocate resources effectively. Those images can also be able to tell us this particular place, there are roadblocks, or the road got damaged, so we cannot use that site to access any or provide any support. So if the damaged infrastructure would include, or some of them would even include like hospitals, which can be used in case of the emergency. We also be able to identify like the affected communities, and this one is useful information in ensuring that we are able to serve the people on the ground. The other critical point, actually it was the initial use of the satellite, is offering communication. During disaster, most likely you're going to have complete loss of terrestrial communication. This is because either there is damage to the infrastructure, or because of the panic, people or everybody would want to make calls, and then we have an overload, and that overload eventually causes a complete loss of communication. So the satellite will be able to offer alternative mode of communication through satellite phone. It can offer internet connectivity, and it can also ensure that we are getting emergency communication system for those responding to provide us with the, you would say, the emergency responders who are on the ground. We can also be able to get to remote locations in the event that there has never even been any infrastructure for communication even before. Then the other part which it is able to help us during the disaster is that we have some component like a synthetic aperture radar, which can be able to penetrate clouds, it can go through smoke, it can even go through darkness, and this one will help us in pinpointing where we have people who require to be rescued. This will make it easier for us to locate who are the survivors. We can identify the exact location of where they are, and therefore the response of such a system will be quicker than when you have to be on the ground and start or try to locate them. Then after the disaster, we can be able to employ the remote sensing and mapping, which is available capacity from the cameras that you have on the satellite. And this one can be able to give us, if we compare the before and after, we can be able to get the land use before and after. We can be able to get the topography, just in case there was something like an earthquake or which changed the actual topography of the setting. We can check the vegetation cover in case there was something like flooding. Maybe there was a wash-off, runoff that cleared all the vegetation. And we also know whether there is water resources available for use by those people who are waiting for rescue. So this one will be able to give us a map which you can now use to know and make better decisions. And I think that should be my presentation for now. And I want to confirm something which was earlier mentioned by Professor from the TUK. You mentioned about aerospace engineering. I want to confirm that we are actually launching it in JQuat starting September, so it's actually accurate. The statement was accurate. Thank you very much.
Thank you for that. And one of the big points I got from that, there is safety with satellites, a lot of safety implications. And sometimes I think about, why do we have so many satellites? Why do nations invest in safety? Can definitely be one, having satellites centrally focused on our geographic location that monitors. And you also alluded earlier to the solar mapping for harvest. And I think we had a presenter yesterday that spoke about Australia's space program getting a major boost from the farmers that were saying that someone else knows how my crops are going to do before me. So us, I think that would be a really strong case in getting the public interested in getting our space program a little bit more attention. We have one more presenter live here, and I would like to invite Dr. Sonia Jita to...
Sorry, Sohan.
Sohan, sorry, thank you. Sohan Jita, right?
Yeah, that's okay.
I completely understand. My first name is Olaolu Alutobi. Some people pronounce it wrong all the time, so I apologize for myself.
No, don't worry about it. I'm dyslexic myself. I'm always falling in these pitfalls. So we're similarly alike, actually. So just that, so that the others know that it's Sohan. But between you and I, you can call me whatever you want. Okay. Yeah. So it's a pleasure to be here. I'm sorry for being late and not being here yesterday either. It's simply because actually I'm on a mission. My mission actually is to set up astroscience education program in various countries in Africa. For the three that are already on the books is Ghana, Nigeria, and Zambia. And today I was talking to the Director General of Kenya Space Agency, my program as to what I want to really achieve in these countries. The way that we're going to achieve actually is, as I said, astroscience. Why astroscience? Well, if you really think about it, Astronomical Union has been pushing forward astronomy past 40, 50 years, right? And astroscience is new kid on the block. And if you try and raise some funding to go to any conference from IAU, the answer would be no. Enter NOCEL, Network of Researchers on the Chemical Emergence of Life. We were formed back in 2013, is my idea. So now we have expanded to include actually 8 other networks. Blue Earth Project to do with the issues of the Earth. ASIN, Astroscience Exploration, which is to head the way forward with astroscience in Africa. A Latin American hub is already operational in South America and is headed by my colleague Miriam, and then there is No Cells Session that's been headed by Professor Savio, can't pronounce his surname, but never mind. And then we have Microbial World Network that is dealing with emergence of life top down. In other words, you take microbes and pull them apart and see how life might have emerged on planet Earth. And then we have Southeast Asia Hub, CSEAC Hub, and they're involved in, of course, propagating science in Malaysia and Thailand and all those those countries. And finally, then there is Frontiers of Science, that's in Yorkshire, the county of Yorkshire in England, which are sort of been doing it since 2015, and we're doing fantastic. We attract about 100 people. And so I took the opportunity to come to Kenya. There was this program going on, and I wanted to talk to the DG of Space Agency, which I did do this afternoon. We had a successful, fruitful discussion on this. And now moving on to the discussions and programs at hand, it's naturally I'm at the rim of this conference, you know. So I thought to myself, I got to do something really positive and constructive. I got to give my input. Otherwise, I wouldn't be a scientist, would I? So I picked up on this remote sensing for mining. And I'm going to be a bit of a devil's advocate. I'm going to oppose everybody, anything to do with mining in space. I'm against it. Because it's to do with this question that we've been asking ourselves, which is this: if life all around us is lunatic, where does human madness lie? To be mining in space, actually, it's more to do with the ego, if you really think about it. And whose ego it may be? I don't know, rich nations? I'll put it to you, ladies and gentlemen, here. Because why do we need to spoil space? We've already spoiled our surface of our Earth. We have decimated the ecosystems. We have changed the climate on this planet. Now we got kind of space debris knocking around everywhere around us. And then what we have was, we got over 4,000 satellites orbiting the Earth, of which, I'll have you know, only about I can't remember my statistics actually, I only read it. I was going to read it off the PowerPoint, obviously PowerPoint isn't on it. And there's only a small number, a quarter of the number, what I've just said, that are actually active. And surely this has to be to do with the human madness. And the human madness is in that question, if life all around us is lunatic, and where does human madness lie? I put it to you that we all are mad. And what do we want to do? Just so that we could be first in space, go out there and kind of destroy not only the immediate future of the Earth, but beyond that, like asteroid belt. They want to do that. I put it to you guys, you can take me on that. I would always vote against you guys. This is not a challenge, by the way. We're here as scientists. We're going to discuss things. I'm just saying that I'm the devil's advocate. And also, that there is a question of Africa. Where does Africa fit into scheme of things? Well, I'll say to you guys, Africa, my friends, you're at the back of the queue. I have a plan which you guys might want to listen, and we can actually put that into operation. Africa will make more money rather than try to mine space. I'm very, very serious about this. And on the 27th of January 2024, Blue Earth Project will discuss human madness, question of human madness. How mad are we really? And I would ask you guys to join us there as well. Whatever you decide here in this forum, or whatever directions we pick and go, I will always be with you. But you do want somebody a thorn in your backside to say something. Listen, guys, it's like this. Let's do it like this. Because I would also say a similar sort of thing tomorrow as well. But I'm not in favor of the thing that I was trying to actually say. The other thing which has been spoiled by mankind is this dark side of the moon. It's now noisy. It's no longer silent as it was. Russians went ahead and put some spacecraft on the other side of the moon. So I think I've got a leg to stand on. Thank you for listening. Let's have a discussion about this. But my stance would only be from a point of view of mining. It will not be any other issues because I'm not an expert and I will not be able to communicate or convince you coherently about climate, about the disaster management, about ocean mining, ocean monitoring. I think I like that ocean monitoring, by the way, if it means that we do for the peaceful, not to mess it up, then I'll agree with you. Otherwise, if you're going to start telling me that, like that disaster happened last month or so, some rich person took some rich people to the bottom of the sea, and if they died, so what? I didn't care about it. I said, hey, listen, go to India, go to Africa, see what's happening. Women getting raped, they're getting killed. Every minute, not only do they get raped, they also get set alight. Look at those problems. Let's sort those out. Why do we have to make a big news about all this? These rich people went to the bottom of the sea. By the way, I'm going to do these projects I mentioned. I'm going to do it. And you guys better be with me on this. I mean what I say what I mean. Thank you very much.
Thank you for that perspective. And just some things I was able to pull from what you were saying is about thinking about why we're going to space, why we're exploring space, why we're doing the things we're doing, and just because we can do it, should we do it, and the impacts of that. And you mentioned something about the dark side of the moon. There was a recent conference with Breakthrough Initiatives, and they're a group that is looking to go beyond our solar system and go to another solar system with their satellites. And there was a presenter, and she spoke about how science is suffering at the use of, as you eloquently put it, rich people decide we're just going to go to space and exploit things. And the dark side of the moon, the area that was the most silent place in our solar system that allows us to listen a bit better, is already getting spoiled because people are doing things and setting things up without having such a conversation where you have opposing thoughts to really question it. So to begin our group discussion, one of the main themes that I was hearing throughout is this idea of disaster management and how we respond to things differently when we know the onset of disasters approaching. If I could offer you a really quick little experience, scuba diving. I was in the process of getting my rescue diver training, and there's a theory aspect of it, and and this also kind of applies to Dr. No, not Dr. Sami, engineer Professor Samir Hamir, when he was speaking about the practicality and theory. So we learned all of the stuff about how to go into the water and protect ourselves if something damaging happens. And I'm in the water and I actually couldn't breathe. My regulator wasn't working, so now the theory became practical and I had to apply it, and it changed my perspective and I thought more creatively. So it leads me into, clearly I survived because I'm here talking with you right now, but it leads me to the first question about, in all of our fields that we've discussed so far, what challenges in our fields forces us to think differently and be more innovative? So if anybody wants to hit that first question about innovative thinking, we can go for it. And this is an open question to everybody on the panel.
Sorry, I'll have to interject. I'm so sorry, I don't know your name, please. Hello?
Yes. Oh.
What is your name, please? I'm so sorry.
No problem. The short form of my name is Toby.
Toby?
Yes.
Hi, Toby.
Yes.
Okay. Look, I just want to go, I don't want to prattle on too long. I just want to say one sentence. I wasn't actually making reference to that we shouldn't go into space. I'm all for it. If you can do it, guys, go do it, right? But I just don't want to spoil it. I don't want to spoil the park. Go for a walk in there. All right, thanks.
Okay, no problem. I just got to note that Professor Engineer Samir had to attend to something, so he won't join us in our discussion, but we still have Cheyenne here, I believe. Are you still here, Cheyenne?
Yep, I'm here.
Okay, so we're going to begin the conversation, please. Oh, Cheyenne, do you want to kind of address that question first, and then we'll bring it into our audience? And the first question we have is, what challenges have you faced in your field that prompted that innovative thinking to come to the solutions that you have right now?
Okay, so it's kind of tied to a bit of my background. So when I did my electrical engineering degree, I did object detection and recognition using neural networks, and that was to help firefighters in smoke-filled buildings, to help find people, as well as the main driver behind that project was also to help find missing people in rivers. Unfortunately, at the university I was at, they did not have biomedical engineering. So, but that was my introduction to machine learning. Regarding, okay, and then during my master's, I designed a microalgal fluidic photobioreactor for deep space to monitor how oxygen production for humans, to see if it was feasible for long-term space travels. Driver behind that was my mom passed away from falling into a coma due to a blood clot in her lungs. So I decided to try and I tried to learn about the human body and oxygen and how plants can help for space travel. Additionally, regarding to explainable artificial intelligence, there's an issue right now. We don't trust machines. And from my industrial experience, from programming industrial machines and training operators to use machines, I realized that for space, it's going to be very costly to trust a fully autonomous system to execute tasks on behalf of us. And if something goes wrong, who's going to be held accountable? So that question I've attended a few legal conversations with that. And one of the main concerns was they don't know what the machine is thinking. They don't know why it's executing how it's executing the tasks. And that's not only applicable to space. Everything around us that is autonomous, we're now applying it to cars. And the question that I've heard so many times was, how can it determine a human from an animal, or to determine which action an automobile should take, whether it should go left or right. I can see where AI, explainable AI, would be very useful, not only for space, but for everything around us. I hope I'm answering your question.
Oh yes, definitely. The challenges that you expressed that you faced really did seem like it forced you to think outside of the box and get more creative with your approach, and also just acknowledging, anticipating what other, the pushback would be. And I think we have people here on the panel that want to continue the discussion.
For me, the one thing that's coming in as a double-edged sword is cloud computing, because on one hand, it's made access to computing power a very good thing. African governments have refused to adopt it, always saying that security is not guaranteed and the cloud is somewhere in somebody's home. So that's posing a challenge, because the beauty of cloud computing is that you can send your commands from your phone and you get your feedback and you're able to act on information much faster and make better decisions. So this is one challenge that we need to continuously engage with governments and policymakers.
Maybe you could start from the beginning. When we started talking about space technology in my organization, which is JCOAT here, and I mentioned it to the student. The perception which was there was initially, this is space, it is out of this world. It's out of the world. So initially there is nobody who thought this is anything that can be done locally. Actually, until we were able to develop the one in CubeSat, that is when they started looking like this is a possible reality. So initially the perception wasn't very welcoming. Actually, one of the initial committee that was set up, I think we only had like a quarter of the members actually being active, because they were still not very perceptive about the introduction of this out of the world technology. I think the other challenge that we still have is that this is still something being taken very new. We've not been able to, I can't say that we've been able to get funding, proper funding for it, because the two projects that we've been able to run it have all come from the Kenya Space Agency. And if you look at it, I would say most of it from the university point of view has been taking a backseat. So until recently is when we're talking about starting now a new course on aerospace, which probably is going to open up the mind of the organization, and funding will become a reality. We're also looking at the technology not sufficiently available locally. Most of the components that are what we consider space grade have to come from abroad, have to come from far. We've not developed the technical skills and level of know-how that so far we can reference and use to reduce our dependency on the outside, I would say. Then there's one point that I cannot fail to mention, is, and I think it has been alluded by other speakers in the past, is that from the reference of Africa, it is being seen more as a market to this technology. And even as my fellow speaker here has mentioned, is that we are left behind. We're left behind, so, and then the part of piggybacking on other countries is not being very welcomed, because we're still being seen as a market.
I don't know what I can contribute any further, other than to add that there are a lot of, I've been coming to Africa, especially East Africa, since 2015. I've visited a lot of schools over, I think, 120, 30 talks and held workshops and given other ideas. And it was that the starting point. That was, I wanted to do something in Africa specifically because I understood where Africa is. And as an outsider, I can see what's going on. And I just wanted to say to the African, as it is, as I say what I observe and tell it the truth. It's better to be truthful so that although temporarily it may hurt, but in the long run, it will work out all right. And some of the ideas I cannot discuss in this particular forum that I found myself in, but I still thank Claire for giving me the opportunity, though. I'm so sorry, I can't add more than that because I think Africa is about 50 to 100 years behind the rest of the world, if truth be known. I know that because I go into schools, I go into the education system. I walked over a guy just the other day in Nairobi City who was lying in the middle of the road. I just did not know what to do. I would have given him 100 shillings, which is what, about 50 pence. But if I had taken my wallet out, I would have had 100 other people stood beside me. And that's why I didn't take care of that guy. I felt so sorry, but please, I shouldn't say anymore because I may say something that may be out of the reach of, it might go into some sort of other areas. So thank you very much.
Yeah, just to follow before we open it up to the audience, if anybody wants to chime in and have a question. One thing I think that rings through everyone's discussion, both virtually and in person, is the delivery system for information. It seems like that is a critical aspect in changing whatever trajectory that we see in front of us. So the last question I want to ask before we open it up to the panel is, what do you think is the ideal delivery system for the message you want to communicate with your field of research?
Yeah, in my field of work, actually, because I work on the astrosciences and I work on the astrochemistry aspect, and I also work on the emergence of life. To be quite honest, I'm glad you asked me that question now. Give me the opportunity because I've forgotten it in my first time I spoke. To be quite honest, my critical eyes, when they look, I see young people with this thing in my hand, which nowadays we call it a mobile phone. And everywhere I see young Africans do have access, those who could afford it, they do have access what goes on in the West. And the last thing that anybody ever want to talk about in terms of education in schools, let alone in universities, because it's literally non-existent in the university to begin with. It is astrosciences. And if you communicate with these young Africans, you will find that they do want to talk about astrophysics, astrobiology, astrochemistry. As I pointed out, that what's also missing from all of this is this. My fellow African, by the way, we helped at NOSAL, we helped over 30 people from Global South. I like to use that word. And 3 Africans have managed to get an embassy, and 1 Iranian woman is on a PhD program because of NOSAP. And what the problem is, so these young African postdocs and even say PhD students, they want to go to the West to present their results, you know? And what do they find? I mean, they find that they actually, not in a queue, they stood outside on the rim of this conference that might be. They never get look in. What I want to change is that I'd like to check, because I'm going to take some action. I have access to over 4,500 scientists internationally. And we've got about 1,000 people on our books as members. But what I really want to do is to change this setting. I would like to invite, get the other organizations like Ungana, ISOL, UpsideCon, other conference hosters. What I want them to do is give 50% of the African students and postdocs some funding for them to go to the West and deliver their science. That's the only way we can make science level playing field. There is no other way. And of course, it's an uphill task. I'm traveling to Ecuador to ISOL meeting, and I've been invited by a university there as well to give talks on education in Africa, which is what I also do, education in Africa talks. And I'd like to actually say the same thing, that it's about time we change. We give more opportunity to the Africans than the counterpart whites over there. And the thing about it is, this, as I said, to narrow the gap, we need to make sure the science which is being done in Africa is at equal par to what goes on in the global north. I really do think that, I really do. I've been writing about it since 2015, about Africa. And all the time what was missing is atrocious that all these big boys, big companies, big this, big that, come along, beating their chest. This is what we're doing for Africa. They're not doing anything whatsoever. It's a showcase. That's all it is. It's a showcase. Oh, we're doing this. Only yesterday, my colleague sitting there, Shirley, she will testify to that. You don't have to speak, Shirley. It's okay. Yesterday, we were discussing education system. They agreed that the way, the direction that I'm taking and approaching education, and they concur that it's somewhat below Western education. What do we have? We have touched. Sorry, did you want to stop me?
No, I was just waiting for a moment to chime in to give others an opportunity to pick up on what you're saying as well.
I'll just do one last sentence.
Okay.
Look, what it is, here's an analogy. In every school, primary, you go anywhere in the UK, at least, I know that, they got touch screen interactive boards, right? And I was in Malawi. In Malawi, it's 2 schools in one. In other words, morning school and afternoon school, teachers are the same, students are different. The only difference is, actually, I'll stop in a minute. Sorry about this. There was a blackboard. Blackboard had splinters in that. So I was going to explain something. I took a chalk, I went across chalk broad. That tells you something about the blackboard, that you cannot write on it, and yet they were calling it education system. This comes from bottom of my heart, and I have wrote about it. And sooner or later, I'm going to write something mega. I recently published a paper in the astrobiology, which you guys can have access to. Thanks.
Thank you for that. And I think we'd like to have Cheyenne speak a bit. She wants to speak a little.
Yeah. So I didn't do my education in Africa, but I did my education in Jamaica. And coming from a developing country, I did electrical and engineering degree. And when I moved to the UK to do my master's, I undervalued my degree a lot because in Jamaica, you hear a lot about contractors coming from overseas to execute jobs and contracts, And when I moved and I started working in the UK as an engineer, the type of education I had from Jamaica, the universities could not afford up-to-date equipment. So I was using really dated analog machines. I was hard wiring, hard coding, binary, hexadecimal, you name it. And when I moved to the UK and I saw that these were the same things that were in the manufacturing industries that have been, I was tasked with my first job here, I was tasked with updating a machine that was over 133 years old, automating it completely from scratch. And if it wasn't for my education from a developing country where the university couldn't afford the equipment, I would have struggled to update that. Also from attending international competitions, when other students from first world countries like the US and the UK, when they went through the scanners, they struggled because the sensors they had, they bought it off the shelf, they put everything together for this robot competition. And when they weren't working, the students were panicking. However, with my group, we hardwired our robot. We built our components. So when it went through the scanners and the magnets affected them, we were like, don't worry, we know what went wrong, and we repaired it on the spot. And I can see where that education that I got, I can see that is slowly dying. I'm in the UK now, so I'm seeing what's happening here. There is I can say that the modern technology, I can see long term, it can potentially impact the growth and the development of the next generation without them knowing how things work from the core.
Definitely. Thank you, Cheyenne, for that perspective. It makes us really value a thing that we've been talking through here, building it from scratch instead of outsourcing it. I think Dr. Nelson might want to speak in a bit, but I think we are running a little bit on time, and I'd like to thank all the panelists for their perspectives. It really got us thinking, and please give us a round of applause to all the panelists.
Thank you all. I thought to echo that. Thank you all for being here. We're gonna go into our last session, and I'm gonna ask Dave to bring up my slides. Shane, thank you so much. You get to stay on if you can. So we're talking about moon landings, how space analogs support Earth, and talking about the future we want, which is making the future we want. And this space that we're building at Oaseas is really a space for everybody to have their point of view. The fact that Dr. Jeter doesn't path the care from man in the moon, for me, is neither here nor there. I have my own opinions about that. Some of you already know that I have contention about what does property rights mean in space. But unless there's enough people raising the issue, and not just raising the issue, but actually putting down some concrete alternatives, you're gonna find that we're gonna drift along a path that we have not thought about second and third order consequences. And my path of philosophy, which I call the smart futures philosophy, looks at helping people understand the word smart in a very particular way. So when I talk about a smart future, I'm talking about always asking the question for your policy or your plan or your project or your process or whatever you're doing. The first question for the S is, how is this contributing to a sustainability system or a sustainable system? recognizing that everything you do impacts something else. It's not just something that's, oh, it's exciting to build and to launch XYZ, but just because you can do it doesn't mean you should do it, right? So how do you examine that thing you're doing? The M for me in SMART is about the issue of metrics. The last 500 years, we've been using the metrics that prefaces profit over everything else. So we talk about people, planet, and prosperity, but prosperity is based on a particular vision of what that prosperity looks like. So we already know that we already have been what they call consuming like 1.5 times the Earth resources ability to replenish itself. That's already a number that's out there. I might have the wrong number, but you get the point I'm making. We're way past. So let's take a country like India and China. They're trying to build a middle class. But a middle class of what level? Is the middle class of the New York level of consumption, or do we want to create a different level of consumption and well-being that allows the Earth to replenish itself? The A then for me in SMART is about looking at the different agents in a system. So if we're talking about Marsabit and we're doing a project in Marsabit, agents in Marsabit are going to be the people in Marsabit. But I would say the animals are also an agent. I mean, they will have sentient consciousness the way we do, but they're also part of a system that allow people to live there. And so looking at it broader than the traditional who has agency to what has agency. If we're talking about nature-based systems, so replenish earth systems, then we have to consider that even the rocks might have their story, as one would say. The R in SMART is about resilience. How do we design for resilience? So from an engineering perspective, we're trying to talk about going to space and learning from that. So we have to build water systems, energy systems, and as we saw for the last 2 days, our resilient communication systems, because if we are right here, we're having so much problems communicating just between here and the MiFi, you know, how are we going to communicate from Marsabit to Nairobi, much less the moon to Nairobi. So we have a lot of work to do. How do we design these systems for resilience and robust resilience? And finally, T looks at the temporal and also the teleological impact of technology. So are we designing to purpose and fit for purpose, and a purpose that doesn't also create a new problem? So as we from Africa hear all of these fantastic geoengineering solutions to climate change, I'm one of those people who tend to roll my eye and say, gee, you know, you can just do carbon capture. Why try to move green sand from Hawaii to the white sand beaches in Caribbean to prove what? I mean, to me, I'm one who was vehemently trying to start a little protest movement. Nobody's taking me on. And then I'm the only fool in the wilderness. And then 20 years from now, when we have created havoc in the ocean, even more havoc, what are we going to do? So all of us who are engineers have to also become sustainability literate. I'm an advisor to a project called Engineering for One Planet, and we're talking about how do we educate engineers of today to be sustainability literate. So that means that engineering schools like JQuat, like National Technical, like Kenyatta, like Machakos, all the schools across Africa have to start talking about sustainability literacy as part of your coursework. It has to be in other words, no engineering graduating from an engineering school in the next 5 years, talking about year 2030, should be graduating without having answered that question for what it means for their discipline. What is electrical, it might mean something different from mechanical, from civil, but it's not just the business of environmental engineers to be talking about sustainability. So if I could ask you to please return to your seats and just do a quick exercise. If you have at least two or three people per table, have a quick exercise that we had yesterday, building on what we did yesterday to talk about how do we make the future we want. So I use this as a tool, apart from doing it as a one-woman show, I also use it as a tool for conversation. So can you go to the next slide? All right, so you have heard my story earlier, and this was my fantasy, my logo of the Upstarts, and the logo for Moonbridge Association. And yes, if you don't know, there is actually a Moonbridge Association, and there's two people here in Kenya that's supposed to represent a focal point, and they're based out of Europe, and their idea is to get more voices from around the world thinking and talking about what might humanity's place on the moon look like. James and Dr. Sohan, if you could just join somebody at the table here, please. Everybody should participate. It's just a self-thinking exercise. It's nothing major, but just to help everybody think about this future. Because we have to design this collectively, right? I am concerned about if we don't, well, I've been told already, we can't slow down the pace of space exploration. It's too late. All right, maybe we can't slow it down, but we can at least ask questions to give people pause. Next slide, please. So this is a person, quick, next slide. Okay, next slide. All right, so some people are talking about the 18th SDG. Some young people out of Europe started this movement. It really has not caught on to some people, but some of us really agree that this is some of this consideration if we're talking about space settlement, space sustainability, where we look at the fact that we have so many satellites that they're becoming a problem unto itself, right? Soon we'll have a traffic jam problem where the satellites will outweigh each other. Who is gonna, they're talking about solving it now, they're talking about putting the rules in place now, but if Africa is only now beginning to put up satellites, and Mr. Musk and the marketeers already decided they're putting up 25,000, then there's no room for you to put up your little 10. There's a problem right there. So you have to be at the table from right now and go into this, making sure that Kenya Space Agency is equipped with a battalion of people, maybe not protesting like on the street tomorrow, but certainly protesting, wait a minute, you guys can't just go and sell our birthright. I mean, as young people, you want to know that 20, 30, 40 years from now, you're not beholden to one company for all the connections that you're going to need to survive and thrive in that future. Next slide, please. And so this question has to be answered. So my first thing was to think about economics differently, and I personally enjoy this view of the economic agenda. It's not yet caught on most economic departments in Curtin. When I asked them, are you even thinking about this approach? No, they're still teaching traditional development economics. It's not working. It hasn't worked for us, but to think outside the box. Why is this important? Because we're reaching the planetary boundaries. We've crossed some boundaries. And it's engineers who have to deal with solving that problem, whether it's ozone layer, climate change, air pollution, land conversion, freshwater withdrawal. All those things are engineering problems in terms of how we design habitat, how we design use of space. And so there are 9 planetary boundaries, and some of them have numbers, some of them scientists don't know. But this is a fact that if we go past those boundaries, the Earth cannot replenish itself. We're toast. So we have to get the engineering economics departments of our schools begin to look at this framework and say, let's think of it differently. So the inner circle is a social foundation. It's saying, we've agreed as humans, we want people to have a certain quality of life, right? We don't want people to walk around begging and for people to continue to be using poor women in India, poor women in Asia, poor women in Africa, with flies in their children's eyes as a fundraising resource, right? So how can we engineer food security, water security, healthcare security, and create a new metric in which we call the safe, just space for humanity, where we don't live outside our means, and we live within the beat of the social foundation. Next slide, please. For me, I preach this. I talk about, all of us should be talking about as engineers, the space, safe, just space for all. We know what 2030 is, next slide. Leave no one behind, but what does it mean in practical sense, beyond the political platitudes? How do we get engineers to think about the space of the SDGs, the 17 goals, 169 targets? One objective is we need to thrive, right? And unfortunately, most of the movies that clutter our mind, and you better even be conscious of it, all of those modern science fiction new movies that you have looked at tend to talk about a very dark area 69, 493, or they're totally a fantasy with blue people. You hardly ever see a future in which regular people in 2050 are walking around Earth, and I like to say, eating a real mango. I mean, why should I have to go in the metaverse and eat a fake mango because we've killed all the mango trees? I would like to know, certainly your children, grandchildren, have been drinking real real rum punch, eating real mangoes, and swimming in real beaches, right? Next slide, please. So for me, when I talk about space for the SDGs, I want all of us to have a story in the back of our mind. So the exercise is, next slide, is to craft your story. And for me, think about space, because we're here and using the space contest, I would like you to think about if you were actually going to be a part of the Oasis mission, right? We're in a mission, we're doing a mission in Marsabit, we're doing an exercise. What would be your name on that mission, your job on that mission? Do you have a particular pet name that you call the moon? And your pet project that you don't want us to work on, and your must-have device. When I say pet must-have device, some favorite device that you have, it may not exist yet, but it's something you want to build, you think, or something that somebody else should build that you would have. So I'm going to give you a couple minutes to work on that individually, and then I'll ask you to share that, and then we'll use that material as fodder for our next quick exercise, and you'll take that with you into tomorrow's exercise. So yesterday we talked about your pet. You cannot know what you talked about yesterday. Now let's bring it into the future. Again, 2030, what's your name, your code name, your individual code name, your job that you personally gonna have. Now suppose you're like Dr. Jeter, not gonna be on the moon. His job might be, I'm on the earth and I'm in the anti-moon mining movement, no problem. He still will have a value because maybe his anti-moon mining movement is going to, it may not stop the man on the moon, but at least will stop them deciding to own the moon. That's the next pet peeve of mine, right? And as worse, could stop the nuclear devices on the moon, which is my real fear. Why should we have, I believe there should be no nuclear things on the moon. That is already a big issue in the United States where people are saying, I'm crazy, it has to happen. I'm very worried about that. How are we going to get about it? It's safe. So they said, until, right? So that's your exercise. You have five. You have, I can give more than 2 minutes because you have a little more time. I did this exercise in 15 minutes, but today we have a little more time. So you have 5 minutes. This is individual first. Your own code name, your own job you have on the mission. That's if you're on the mission, if you're on the earth. This is an analog mission, by the way, so you're not yet in the moon, so you're doing analog. Analogs are simulations, right? So you're still either in the mission itself or you're in control, or if you don't believe in it at all, you're doing something as maybe to prevent that from happening. Yes. So I think African should come there also. You might have different name if you want to bring it. So in case you're confused, pet name for the moon means I'm recognizing moon is just a name, but every culture has a name for it or a symbol for it that might be different from the British word moon or English word moon. So you might have your own name if you want to call it, that's fine. Pet project means your favorite thing you want to work on. And pet must have devices like the device that you will have to carry with you on this mission. that may not have been invented, but will have been invented by 2030. Perhaps it's something that you yourself are working on right now and hope will exist in the marketplace by 2030. So it doesn't have to exist at the moment. All right, you done? Next slide, please, Dave. All right, so you know who you are. So what have you successfully worked on? Actually, yesterday, some of you were here, may not have been here. So if you weren't here yesterday, what is your success story? It's appearing in some podcast, newspaper, but something that you have worked on, something that you yourself have worked on. 2030. You know what you're working on now, your passion projects, the things you want to get into. So for me, my headline would certainly be, and I have more than one, but let's say if I could combine them, like, you know, Oaseas has 3 locations across Africa. It all began in 2023 in Kenya. They opened that desert facility, then they opened the cave facility in Nigeria. 3 years later, in the next 3 years, they opened the facility in an island underwater cavern on the coast of Cape Verde.
Sorry for my naivety. What was SDG stand for?
Sustainable Development Goals.
Oh, right.
And Oaseas work has been successful in addressing life beneath the ocean and also addressing issues of energy. In fact, they have successfully created a microgrid of energy companies that supports energy companies all across Africa, rural Africa. So for me, that's a thing I think about every day. How could this happen? How could this happen? That's what I think about. So I'm intentional about going to masturbate the book that some people will come along and help us figure out how we're going to get affordable, clean energy that's least destructive, that thinks about predictive use of the panels or whatever energy form we use, so we don't create a new problem when you have those solar cells out there, then there's toxic waste, then what? So a lot of things to think through to solve the power problem. How are you going to get rid of those things? So that whole thing has to be thought through, the whole circle of engineering, symbiotic engineering approach. So I invite you all to share now what you have written, and then we'll be done for today. I'll actually process it a little bit of it, and then tea is ready, so we can just relax and talk informally after that. So I'd like you to share at your tables what you talked about, what you wrote, and see if you can fine tune something that you can now share. And I'd like to actually hear from each table very quickly something in common out loud, so we can see if there's any commonality around the group. So I'll give you 3 minutes to share it among each other first, right, at your table, before I hear from you all. So if there are people online, maybe what they could do is meet in the meeting room. There's a session room open, Charmaine? Probably not. I think you can't have both. You can't have session and stage open. Oh well. You probably can talk to each other in the chat. So anybody online wants to share online, I'll process that as well, or respond to you individually. This hopping platform stays open until tomorrow evening. Any camera? But up here? All right, so we're gonna So we're gonna have a quick process. If anybody, not to say the whole detail, but if anybody said anything really interesting that made you go, or y'all laughed or went weird, I'd love to hear that. So who wants to be spokesperson for this group? This table. Alpha table.
Oh, yeah.
All right. Attention, everybody. All right. Table. James. What interesting did you hear?
Oh, we're just discussing his name, his pet name. And what was the pet name?
My pet name was Olua Sunil because Olua is part of my first name, and Sunil is in one of the Indian languages that also means part of my first name. And then we had a commonality. If you want to take it over here.
Yes. So
the name common when you said Sohan means.
Oh, well, Sohan means beautiful boy.
It's interesting what will come up in this conversation.
Okay, interesting. So for us, we had a number of things, and what was coming is that we were somehow having interest in food and conservation. Yeah, so for me, it was more of being a geotech farmer and ensuring that we can have a precision farming, some sort of control. And for the device, I must need a drone and a laptop, I think. Okay, now taking it to the community, we still need the drone so that we will know where to do what. Yes.
All right. Curious. I always love to hear people talk.
Hi. So one thing that we have in common between the two of us is we are passionate about the gender space.
About what?
Gender space, equality of the Jedi, G-E-D-I.
So from now on, you can start writing your hashtag Space Jedi or Jedi Space, whichever. This table.
I'm very interested in water resource management. So my code name is Mama Maji. Water, and my space job shall be a rainmaker. And my pet name for the moon is Mweri, which is from my indigenous Kikuyu language, which means moon. And my pet project is called the Maji Maji Revolution. And my pet must-have device is what I actually have two. One is an element sensor because I was thinking of how we can sense for hydrogen and oxygen so that we can make some rain. And then a water wand. I have collaborated with her, she's giving me some good ideas for recycling body water. So I went all the way. So my success story, my headline is about the celestial water maker. And what have you successfully worked to address? So my body, my water. So we want to turn sweat to water, breath to water, urine to water.
I'm telling you, there's a whole story right here. I think you should be part of the project for Mama what? What? I love it. So I can imagine her on a mission in her flight suit, right? And that mission maybe to figure out what if there was a water disaster. Like, so let's say the water systems broke down and there's no water coming up from Earth for another 5 days. Time it takes to load a rocket, a shuttle come and bring you water. You only have 25 ounces of water left and there are 5 of you. How are you going to survive on 5 ounces of water a day? So that might be one of our research projects. I'm serious. I'm thinking, what are we going to be studying this analog, and how does it also help eventually solve a problem on Earth? Who will go for this table?
Good. So for this table, what we had in commonality is innovation, but I think for everyone, we just been asked to be innovative. But we had innovation, wild ideas. For myself, name or code name, Mr. T. Mr. T. Mr. T. Yes. Yeah, my name is Tony, so it's just yes. Then space job, innovator. What they call the moon, the big ball. Okay. Then the PEN project, the SDG, a perpetual energy source. Come up with something like that. Then a must-have device. Now this would be a device that can predict consequences of each action.
That's a nice one.
Okay, I'm thinking about it in terms of AI, where we're taking AI to. It should be able it's because it's gathering data, now. This is basically what's been happening when we do this. So, like we're talking about the oceans, pollution, everything, we're able even to predict, like now we're able to predict, or what Shelly or something, what was her name? Yeah, she was telling us about now, by just viewing how it is that the sun is appearing, the water is receding, then you can already predict that tsunami is going to happen. So there are actions that could lead to us now, something like that. So there are small things that you could do that could lead to something like that. It's just as simple as even what you talk about, don't drink and drive. So when you drink, what are the chances of causing a crash? Something like that. Okay, so it is doable. I think that's something that's doable. Then headline. So weekly rocket launches from Malindi. How did they do it? So this one comes from yesterday's. So how did Kenya do it? Just like now what Elon Musk is currently doing. It's possible for us to be able to tell. Yes.
Well, actually find out now that you guys are actually working on a rocket launching for fuel propellant. I now only want someone to start on the shuttle. That's my pet project. I would like to see somebody or some combination of universities in Africa build a shuttle. So we have come to the end of today's formal session. We have tea next door. I'm here, but before we break, I just want to remind people we have postcards from the future here, and I have noticed that only 2 people have even started on the artwork which we put on the table for you guys to fool around with. Now, none of them have been finished, so I can't give my prize, but Mrs. Oh my God! So 2 have been, so give him a hand, and without instruction, he has completed 3 pieces of art. So I think he walks away with the gifts for today, right? Because what was interesting, and I didn't announce it, and he was just thinking, hey, this is here for some reason, let me start doodling. And so his doodles have pronounced him the winner of today's book package. You get to walk away with 3, not just 1 book, you actually get 3. Wow. So I'm going to give you 3 books. Let's go! So this is the book that Rose talked about, right? And I'm really happy it's going to Leah Sky person because they're really trying to work at the grassroots with schools. So maybe there's something in here that you guys can use to develop, their material. This book is a compilation of essays. It's published by a company out of London called Fast Future. And I have an essay in here, that's why I brought it. So there are many different essays. It's all written by futurists. And the beauty of this book, we were given some specific instructions. It was 2020, COVID had just hit. We had to write something that would happen by 2027. And my story, there are 2 people, there's a Kenyan guy who also wrote in here, so you can have, and ours are the only 2 regional stories. And my story talks a little bit about Africa
and it's called Africa Rising. And this came out of my pissitude of about when the French guy said, oh, we can just test the vaccine in Africa. I got really upset. And so a bunch of us were upset. And I said, why is there this assumption that we'll always be the underdog for people to just come and, do what on? And so I wrote a story called Africa Rising, and I created this fictional movement, which to some extent exists in my world because I'm always trying to see elements of it. And it had to be written by 2027. So I'm only 4 years away from this. So it could happen, it could not happen, but some variation will probably happen. And I talked about the smart futures paradigm, which funny enough, the book had not yet quite been written or published, but I was already thinking about this concept. And so the smart futures paradigm came out of it, and it talks about the Africa Caribbean Pacific Alliance, a CARPA Rising, a civil society forum, and we're having the third event, talks about a pharmacy in a box, clinic in a box, and all the things that a lot of us were talking about at the height of COVID, solutions that we had in mind, and it's all in here. But beyond, there's lots of other stories about the future, and I think you guys can definitely use it to help, use excerpts of it to help drive change. And finally, a copy of my book, Smart Futures for a Flourishing World. And this book is my treatise on the future, and what makes it different from traditional nonfiction books, that I have fictional stories in there. It opens with Anansi. Who knows about Anansi? Yes. Right, so Anansi is a West African trickster god from the Ashanti people. So many Ashantis, Yorubas, Igbos, Fanti were brought on slave ships to the Caribbean and America, and Anansi shows up in our folklore. So I use Anansi as a modern day device. So I use and create new Anansi stories. I don't just tell traditional folk tales, I tell new tales. And so in this story, I tell the tale of how Anansi helped to save the world. This story is set in what I call no time. And according to my story, again, written with COVID in mind, the gods are meeting to decide the fate of humans. And what I've done is I've tried to conflate all the gods. So whether you are Norse, African, Pacific, Maori, Greek, you're in there. And part of the reason why I really wanted to kind of deconstruct this idea that only Greek mythologies and Roman mythologies have value in a global space. So the gods are meeting, and chaos is leading, called chaos is a god in the Norse tradition. Just like, what is with these humans? They're about to destroy the world. We need to probably do it over. And so Anansi, who has snuck into the meeting illegally, he's always up to some tricks. He really shouldn't have been there because he's not really a god, he's more like a semi-god. But he convinced his boss to take him. And he's like, oh my God, if they destroy the world, I'm gonna lose my job. I'm the head negotiator with the humans. And so he basically gets the gods to agree to put a pause. So in my head, the pause is the COVID, in which we have a time now to rethink. And he goes out and collects stories, seeds of hope. And so I have him starting in the year 3000, going backwards in time to the year 2100, the year 2070, the year 2050, and the story ends in 2030. So that is our first collective date that we as humans have said, we've got to do something different to save ourselves from self-destruction. So for me, who is worried about self-destruction, it's a way of my sharing my passion for design thinking approach, which I think will help more people produce theologically effective engineering solutions. And it ends, at the end of that, I close the story which says, so Anansi, which is a male figure, calls his sisters and cousins, Grandmother Spider and her sisters. Grandmother Spider is from the Native American culture. So Grandmother Spider comes in and she has to collect all these stories of hope. And so I'm leaving room for each reader to write their own story of hope as to what are they doing that will take us across this chasm where we're either gonna turn around from disaster or we're gonna run over the cliff. And I'm hoping that Africa can be part of the turnaround story for ensuring that humanity is not taken over the cliff by whether manufactured viruses in labs we know not of, whether by AI run amok, whether by a space war being started because we haven't come to terms with the fact that the moon is shared space. Space is shared space. It doesn't belong to any one company or country. And so this is what this is. So thank you so much for being an active.
Photo up, please. And let me tell you, the book is very well written. It's very engaging. It's really, really engaging. So I would recommend that you all treat yourselves to it. You treat yourselves to so many stupid things that have no value. Treat yourself to one of those. Hold that photo up for me, please. And Nancy. Awesome. Awesome. Could you step a little bit to the left for me so I get these two space person? Right there, right there. Go, go, go. Too far, too far. Too far, too far. Yeah. Go back a little to your right. Yes, that's excellent. Awesome. And where is Isaac? Did Isaac get a book?
No, Isaac did win a drawing.
Isaac deserves a book for all his other stuff.
All right. So thank you so much. So with that, tea served next door.
Yeah, you never showed that. Claire, look at that. Somebody was sitting beside me, so she's outside. She did that drawing.
She didn't finish hers?
No, she didn't finish it, but I think she started it. Wow. Oh my gosh. This is so fabulous. My grandson love these.
Let's close it down. You can close it down, Dave. Close it down. I do that tomorrow. I do that group story. I do that one tomorrow.